Good morning, everyone. We're just gonna wait a few more minutes. We have a couple other people in the lobby before we get started. So please be patient and we'll start shortly. All right, good morning, everyone. I think we have a majority of the people that registered. So we're going to go ahead and get started. I want to let everybody know, I'm sure it warned you when you joined the meeting, but this meeting is being recorded and will be available on Nevada Department of Agriculture's site after the meeting. So I'm going to go over some Zoom controls for right. Everyone, his video will be enabled and the chat box will be open. However, the mics won't be on or available until we have the panel discussion at the end. And our Zoom operator will be unmuting everybody at that time. If you have questions during the presentation, feel free to type them into the chat box and we'll address as many questions as we can during the panel discussion. If there are any questions that we don't have time to address during the panel discussion, we'll make sure to put you in contact with somebody that can answer those questions. And as you can see on your screen, this is the participant and controls. So at the bottom of your screen, you should be able to see this yellow highlighted box where you'll be able to start your video if you wish at this time. And then once we open up the mics, you can mute and unmute yourself. As well as you can see the participant, click the participant box and see all of those that are participating. Open up the chat window and have any reactions if you'd like to raise your hand for questions later on, or give a thumbs up if you agree. And so if anybody has any questions, please, about how to use Zoom, you can put them in the chat box or raise your hand, and Liz Munn, who is helping us from the tech side, will hopefully get to you. I'm going to go over a little bit of the background of the Nevada Native Seed Partnership. Our partnership is of state, federal, and NGO agencies that share the same vision. Our vision is to keep Nevada's lands diverse and functioning by using the right seed in the right place at the right time. We are working to accomplish our mission of partnerships helping to increase the availability of genetically appropriate seed and to restore diverse plant communities and sustainable landscapes. The goal of this forum is to connect growers, share information about production, collection, and selling of seeds in Nevada. And as you can see on our screen, this is the makeup and partners from our state, federal, and NGOs, and really like to thank them for their participation in helping to make this forum possible and for the continued work in Nevada to create more native seed. So since we have 93 participants today, doing a round robin introduction would probably be the entire forum. So what I'd like to suggest instead is for everybody to introduce themselves in the chat by putting their name and their organization or farm or who they are with, so that everybody gets a good idea of who's participating. My name is Megan Brown, and I work for Nevada Department of Agriculture, and I really appreciate everyone being here today to see all the enthusiasm and really a diverse geographical and organizational base for our participants. So thank you all for being here today. Day one will be focused on producer experiences of growing native seed. Following the presentations, we will have a panel discussion that will be moderated. Questions will be asked either live or via chat. Although this is a virtual format, we want to make it as interactive as possible. We will also have poll questions that are going to appear throughout the meeting to help us get a better understanding of our audience and their needs and interests. And it'll also really help our panel speakers understand who they're talking to in this kind of, excuse me, in this virtual world. And so those poll questions will pop up and the answers will be visible afterwards for everyone to see. So I think we're going to start with our first poll question. If we can get that up, thanks, Liz. Please feel free to enter in, and then we'll move the meeting over to our first speaker.
Well, good morning, everybody. My name is Russ Willem. I'm not the first speaker by any means, but I will be introducing him. Thanks so much, Megan, for that wonderful introduction there. Welcome everybody to this meeting. Our first speaker on the agenda, his name is Matthew Benson. Matthew Benson is part of the BFI Native Seeds and Benson Farm seed production and restoration operations, located in the Columbia Basin, a major seed growing region in central Washington. BFI offers source identified grass and wildflowers from across the Intermountain West. Okay, Matthew, so you've got the floor. Feel free to go ahead and share your screen if you can. Keep that figured out again.
Okay, I got the unmute. Now let's try to share the screen.
Hey, Matt, why don't you just take 1 second and let's finish this poll. Let a couple more people
all right.
answer. Sorry, I relaunched it. Sorry, folks. Little learning the tricks of hosting a Zoom meeting of this scale. So we'll just give it 1 more minute, let a couple more people answer this question. If you've already answered it, just answer it again. It's no big deal. And we'll get some data from folks. Let's give it another 20 seconds. A lot of words on that. All right, looks like we've, so folks should be able to see the results now. Looks like we have a lot of folks that have some direct experience growing some seed, some buyers and some users. So thanks for sharing that information, folks. And I will stop sharing results. And now you can go for it. Thanks for your patience.
All right. Let me try again now. Let's see if I can get the right screen. That's showing up the way everybody wants to see it.
Looks great.
All right. Well, again, my name is Matthew Benson, and I do work for BFI Native Seeds and Benson Farms. Pretty much the whole intro there was what I was going to say. Yes, we're in the Columbia Basin, and it is a major seed growing region, and we've actually been growing source identified biotypes of grass and flowers since the early 90s. Our first foray was, well, again, it was a switch in agriculture a little bit. We'd grown a lot of seed before, but it involved me standing on the back of the drill with a stick and jumping up and down and shoving all the seed into the tubes to make, because the stuff wouldn't feed. And so if you've planted much native seed, you probably have had these experiences. And so something I'm not sharing that you don't know already. Excuse me. So I will start with the warning, because things could be said that you won't like or agree with, and that's okay. It seems less okay some days, but I'm happy to debate, happy to let you be wrong. And, you know, if I offend you, it's with goodwill. It really is. And I was told that I'd be shedding light on the native seed industry. It might be blowing sunshine, and that's okay. They're similar grammatically, at least. So let's take a look at, let's just dive right in before we get very far. Why are we planting native seed? Why are we trying to use native seed? And I think that's a really big topic, actually. But so I threw one on here that involves negative non-pecuniary externalities. I don't know how familiar any of you are with those. It has a lot of buildup to it, and I did not want to take the time to go into it. But the idea is, are the effects of things that happen actually priced appropriately? You can go back and forth on that. And again, I like this because I can't hear any booing out there when I put this up. You're all very familiar with the idea of the tragedy of the commons, and there's probably some preaching to the choir going on here, but we may not recognize all the features and functions that don't get taken care of in the way that much of our landscapes are managed. And so to that end, I'll hit one maybe a little closer to home. We went from extracting hydrocarbons to now extracting carbohydrates. It just depends how you like to have your ecology extracted, I guess. But I would think that, again, if you could point to it and think a negative non-pecuniary externality, things that happen to the environment that are not priced, you know, we understand that something negative may occur, but not only is it negative, it's not been priced. So there's no coming back to it and saying this is what it was worth. And it was external. We didn't even see some of the effects. There could be more negative effects than what we see there right away. It's very easy to work in a first order environment where we say, oh, yep, this is what, it's a static system. Static systems do this. And that may not be the case. And so is that normal? That's normal human thinking. Myopic and selfish. That's what we do. That's what it means to be a person. but maybe we can be better people too. Yeah, I mean, I know this sounds very large and philosophical, and why did he start with that? It's so boring. Just if I don't set it up for the framework to say, yeah, maybe it isn't what it could be. And so to that end, you know, it is what it is, and understand that. And so that's why we have to say, what's our solution? How do we look at this and come up with a solution? Because it's easy to say, well, I blame the market. Well, I blame the state. Well, I blame all these things. It's all rigged, right? I mean, this is state of Nevada, so I think we all understand the house is going to win. The game's already rigged. So it's going to play out a certain way. How are we going to be involved in that game anyway to a better end? And that's going to roll me to kind of what started BFI into this. Here, as opposed to the last two pictures, you're looking at, looks pretty nice, actually. Pretty diversified and interesting plant community going on there. lot of different things actually across, obviously not the best landscape. You can see the rocks. So that lets you know it's not a perfect place by any stretch of the imagination. So it's a site like this, a nice remnant of native habitat many years ago that my father, who worked for the Washington State Department of Fish and Wildlife, saw and said, hey, we got this on this side of the fence and we need to switch this property on this side. Let's make it work like that. Let's make it look like that. The difficulty being, he opened all the manuals that were out from, the SCS and everything he could find. And, on the market, there were these cultivars that were available. And they said, here's the pieces you need, and you can recreate a diversified and healthy, sustainable native environment. So spent, 4 or 5 years doing all the steps, making it work, putting in the materials that you were told, following the manual, and was a failure, a complete and almost utter failure. Did not look like this side of the fence, did not behave that way, and was never going to get there, unfortunately. Which drove the question, what went wrong? Why isn't it working? And again, a lot of different ideas and a lot of different conclusions are going to come. Every one of you would hear that question and say, well, I think it'd be this. And another person, well, I know it's this. Well, yeah. We picked one. We picked one in this rigged game and said, maybe the plant genetics in this environment were not well adapted. And if we put something there, what if we went over the fence, picked up these, got enough seed to come back to our side of the fence, plant them again, and see what happened? And that, there is a nutshell, is what we did. Which leads me to the idea, some people think, hey, one silver bullet, one's good enough, one's big enough. Here's Sandberg bluegrass. All of these are 1-year-old stands, all planted from different areas, not that far apart necessarily. You can see the locations, you can see what they do, but you can see they all have a very different expression. They are not the same thing. And I'd just say this was, I don't want to say breakthrough because this ain't rocket science. Went to the other side of the fence, put it on that side of the fence, not rocket science. But realizing that, the one generic item in the market is probably not the best item for getting done what needed to be done there. Maybe that isn't even a good system to do it. Maybe what we're calling the market isn't actually providing a clearing mechanism that gives us what we need. So we began developing our own genetics here to take to the sites we were working on to try to get that done. So that was an example for Poa secunda. And again, I wish I could see your faces, and those of you who are sticking your tongue out, I just can't. And that's because then I could pick on someone. But next up, blue bunch wheatgrass, another popular one. And again, these are all year 1 plantings. So they're all actually not even 12 months old, 9, 10 months old here in these pictures. You can see the locations they're collected from, and you can see that they have a very different expression. These are all on essentially the same field, or fields directly next to each other, not right next to each other, because yes, isolation. Yes, I understand that about growing native seed, but they're all very near each other, grown on the same farm, grown under our cultural methods, and yet you can see 3 of them expressing entirely differently. Could that have an impact then when returned to the environments that they're supposed to be used in restoration? Yes, I think there could. I think there could. One more, just to prove my point, because I obviously feel unsure about it. Blue Wild Dry, same setup again, all 1 year grow out, planted, grown. And in that first year of expression, what you're seeing, 3 very different looks, essentially from things that are, again, very close. 2 of these are right out of the Blue Mountains. But in the Blue Mountains, you still get a whole lot of adaptation to local whatever local, is it soil? Is it water? Is it nutrient? Is it seasonality? I mean, all the different things that cause this to happen, you see an adaptation taking place. So to get that done, here's where I shift gears, and we'll go to how this has to happen. And I don't know how familiar many of you are with the farming of native seeds, but I'm going to start showing farm pictures. This is the part where we can go, oh, good, he's finally not talking about that other stuff. And so here's a picture of some of the work we do on our farm. And to get these native seeds, again, there isn't a market, or there wasn't a market, or that market is small. There is no one source clearing for this market. There's not like, oh, well, what's the market today for this today? Well, it depends. It depends. What are you looking for? Who's grown it? Does it even exist? And that leads to all those things we have to get. You can look in the upper right corner. That's collection. We have to go out and find the pieces that we need to grow out before we can even move to the next step. To the left side, you can see what it looks like when we do take that collected material, do what we can agronomically with it. And I will tell you, the agronomic adaptations are not there in something that you pull right off the hill. It is very difficult. And sometimes it drives us to having to do it in very small plots to start. As you can see down below in the lower right corner, we grow a lot of times, we have very limited amounts of seed that can be collected sometimes. And we have to grow each plant individually in a small plot. And each of these flowers, harvest them as they come off and are ready to get enough seed to even begin to do anything. So there's a real plant material development angle to doing what needs to be done to meet these needs too. And a quick shot of the machinery yard. When it seems simple, you have to look at how many different pieces of equipment it takes just to get the fields to grow. It's actually an enormous amount of work. Enormous amount of work. Next, moves on to a little more. You can see hand harvesting, like I said, or that hand planting that occurs. You can see the precision with which we have to be able to get in at, and the facilities even for handling the material once you've grown it. Once you've harvested it, once you've grown it, we move a lot of material to the drying sheds. And to set up these big drying sheds, again, if I'm shedding light on the industry, there aren't a lot of secrets. What there are a lot of is hard work, just lots of hard work. It isn't like, oh, but you found the one thing that'll do this. No. Just put in a lot of hard work to get it done, which then would relate to why the price of some of these items is what it is. But we won't go there right now. So once you have it cleaned like that, then it takes a lot of milling. And unfortunately, we had to build our own mills too, because you couldn't even find really anyone who would take on. I mean, walk up to someone with a big pile of flowers and say, I have all these dry bags of flowers. Can you make this work? And most people say, we don't do that, or we don't know how to do that. And the few people that do are saying, well, we're doing it for ourselves already. We don't have room for you. So it drove us to have to build also our own milling setups. And we have several different milling setups because sometimes you are doing one handful and sometimes you are doing truckloads. And so to match that, we've had to scale with a lot of different ability to size for what we're trying to work on. Scroll down again here. Oh, there's that product. So that's what you want to see at the end of it, right? That's what you try to get down to, because the idea is you're going to get a product that's going to be usable to put back on the ground. And the methods that we have for putting things back on the ground generally involve feeding seeds back out there. Nobody wants to take the whole field of material. It never seems to be a popular option. People do want to see, oh, bag of seed. Oh, and it has a certain purity and it has a certain live amount. Yeah. And the biggest and most interesting part is it's actually there. So we can quibble about, oh, how good it is, but the fact that it's there versus not, is probably one of the biggest things that takes place in the source identified native seeds, because just having it, most of the time you're not going to have it unless someone has taken that step. You can see all the steps that we put into collecting it and getting it grown up, increased into a larger production, and getting it cleaned down and dried and into a bag. Well, all that takes time. Unfortunately, about 5 years from the day someone sitting there says, I got a restoration project and I would like to have the materials that work. Okay, great. Good idea. Good idea. You got 5 years and it's going to take some money too. Yeah, that's how long it takes from someone having the idea, going out, getting the first material, getting it increased enough, moving that into a larger production, ending up with something that's finally in the bag. I think sometimes we miss what kind of investment that actually takes to get that done. It isn't just dollars, it is time. And you can't get that time back and you can't speed it up either. We have a biological supply lag. It is a feature of natural systems. Which again, we built most of this. Again, where do you find, why would you do this? Because we were doing restoration already and we've taken on doing more restoration. And there is demand for it at a level, but again, not all the parts or pieces of the puzzle were always available. And so we knew that buying something, sometimes things that were, you call a substitute, you call maybe next best, and that wasn't working, or it wasn't always working. And so to keep our restoration operations doing and the projects that we were working on, we needed those genetics. And then once we had the genetics, yes, we sell it, but then we realized, wow, we sell this and then people don't necessarily know what to do it. I'll take it out here in end of May and sprinkle it on the ground. Well, that's not going to work, well, but I have open dirt. Just because you have open dirt doesn't mean you have a project. Yeah, we found that the same energy and knowledge it takes to get these things to grow well in the field can also be applied to the restoration environments. And it needs to be, because you'll read about lots of, it wasn't successful using natives, or, well, luckily the cheatgrass grew. Well, luckily, yeah, because I guess as opposed to nothing growing in the dirt going all the way away, there's trade-offs. Well, in this case, we said we need to actually build things that work. And so, yeah, to feed our own restoration operations, we had to, and because we knew we had good material, we took on doing more of it. So that's the shot you're seeing there. Oh, and I came to the end of it there. Lucky you all. I maybe even was a little fast, but looking at a field of Great Basin wild rye, which is a great grass, in the sunset, that kind of gives it to you. And there you are. I wish I could see your faces and take questions right away, or even criticisms. I'd take them. But I will move on and let somebody else do this.
Hey, thanks so much for that. Let's see, I gotta change my view now.
And I see, sorry, Liz,
Go ahead, Megan.
I did put a reminder in the chat as well. We're going to take questions at the end. So I see 2 RS Brian has his hand up. We'll make sure to make note of that and call you when we have our moderated panel discussion at the end. Or you can feel free to put the question in the chat and we'll be monitoring those as well. So thanks, Matt. And I'm going to turn it back over to Russ if he's there to introduce our next speaker. Thanks, Russ.
I'm here, Megan. I did not go anywhere. Sorry for stealing your thunder on that introduction there, Matthew. I apologize. But I want to just thank you again for such an incredible presentation. You really did blow some sunshine on the native seed industry for us there. So I don't know, are we going to open up another poll question here? Or are we going to wait? No, we'll wait on another poll question until later on in the agenda. Okay, so with that, we can stop screen sharing, and then ultimately what we'll do is we'll switch over to Patrick Reynolds with Hedgerow Farms. Pat, so if you want to get set up on your end, I'll go ahead and give you a little intro also.
Okay, sounds good.
All right, so Pat Reynolds is a restoration ecologist with more than 25 years of experience in the design, implementation, and monitoring of habitat restoration projects. He is currently the general manager of Hedgerow Farms, where he brings native seed and plugs of known genetic origin to the market.
Okay, thank you. Can folks see my screen?
Not yet.
Not quite yet, Pat.
Okay, all right, let's see.
So hit that screen share button.
Okay, all right, let me get out of here. Okay. How about now?
Let's give it a second. Not yet. It's always a hiccup. So, Pat, you got that, that there's that screen share button, and then you can select the panel that you want to share and then hit OK.
Yep, I got that.
You got that.
So I'm hitting screen share. Try this again. What about now? Does that come up? No?
No dice. Well, this is why we have a backup plan.
Okay, very good.
So let's see if I can pull it up for you. It's going, and I will give it a go. Share that. Try and get this nice and big for folks. All right.
Okay, I can see it. Can everyone else?
Yep.
Yes.
Okay, excellent. All right. Well, good morning, everyone. My name is Pat Reynolds, and I'm the general manager at Hedgerow Farms. And I'm going to tell you a little bit about how at Hedgerow Farms we produce seed of known genetic origin for habitat restoration projects. Next slide. But first, I'm going to tell you a little bit about the history of Hedgerow Farms. Hedgerow Farms was founded in the 1980s by John Anderson. John Anderson was actually a veterinarian at UC Davis before he started a second career establishing Hedgerow Farms. And John Anderson did a remarkable thing. He basically figured out at a time when there was very few folks that were producing native seed, how to take seed from the wild, how to grow that out, how to clean that seed, how to store it, and how to bring it to market. And it's really because of the remarkable work that John did that we have all of this great seed in Northern California available for habitat restoration projects. But the other thing that John Anderson did is that he started to work on establishing habitat around the Hedgerow Farms farm. He essentially went and built hedgerows around each of the fields. He produced tailwater ponds to take drainage from the fields. He made bioswales. He created seasonal wetlands. He expanded riparian corridors. So John, at the end of the day, really provided an excellent example of how habitat can be incorporated into farming. And so it's because of what John did, both establishing Hedgerow Farms and producing the seed, as well as showing how habitat can be incorporated into a farm, that he became the first ever lifetime recipient of the Habitat Restoration Award for the California chapter of the Society for Ecological Restoration. Now, John, unfortunately, passed away in 2020, but his work and his legacy is it'll continue on for many, many generations. So anyway, a little bit more about Hedgerow Farms. So Hedgerow Farms has about 350 acres in production. Everything that we produce is seed of known genetic origin. As part of this as well, we have about 100 acres of habitat as part of the farm, as I was describing. We grow out about 120 different species of mostly grasses and forbs, but sedges and rushes as well as part of that. And within that, we have many different ecotypes a lot of times. So, probably at the end of the day, we produce more than 200 different items here at Hedgerow Farms. We also have a native plug nursery, and we also sell our native grass straw, which is really a great product for habitat restoration purposes. Next slide. So the process of growing out seed of known genetic origin starts with the collection of wildland seed. So it really is that stock seed, that wildland seed can actually often be the limiting factor when it comes to being able to grow out this material. You have to locate the sites. You have to be able to get permission oftentimes to be able to collect the material. Oftentimes that requires permits. You have to make sure that you're properly identifying the species. We work a lot with UC Davis here in Winters, California. We're pretty close to UC Davis. So if there's any questions about species, we work with the UC Davis herbarium with that. Sometimes we work with contract seed collectors. One of our sister companies, Pacifico Seed, they actually have a contract wildland seed collecting crew that we work with on some projects. But a lot of times, actually, the original stock seed comes from contract grows. That's where folks come out and they need very specific local genetic material, and they provide us with that stock seed that we then grow out into the field. And I'll talk about that in a little bit more detail here a little bit later. Next slide. So when you're collecting that stock seed, it's really important to have good documentation of that. That can come into play later when folks are trying to design their habitat restoration projects. Obviously, the coordinates are the most important thing, so you have to make sure you have the data on exactly where that seed came from. With that, you'll get elevation information, which is important. Soils can come into play as well. Running a free web soil report actually is kind of a nice, quick and dirty way to get some information on the soils at your collection sites. Having some data on associated vegetation can be important, as well as knowing about the aspect and exposure of those collection sites. And then we also like to document the access and the permissions that we've gotten to be able to collect that material. Next slide. So the seed collection windows, the stock seed collection windows can vary. Like cool season grasses, stipas and elmises and melicas, for example. Usually that material is, at least in California, it's not ripe until sort of late spring to early summer. But warm season grasses, those grasses that really actively grow in the summertime, deer grass, threons, alkali saccatone, etc. That material is usually available in summer or fall, late summer or fall. And native wildflower species, they tend to be ripe when depending upon the particular species, right? It can be early or late depending upon the species. One of the things that's really great here in California, we have this resource called CalFlora. And if you go into Google and you type in the scientific name of a given species, generally CalFlora will be one of the first 5 choices on that. And you type in you click on the CalFlora icon and you get this really great initial page that gives you the general distribution of the species, but it also provides you with this little clock you can see in the bottom right, the bloom period. And that's really kind of a nice little piece of information to give you a sense for when a lot of this material is ripe. Next slide. Okay, so one of the more complicated endeavors associated with growing out seed of known genetic origin is the placement of the fields. So if you look at that colorful map there on the right-hand side, each one of those different colors is either a different species or a different ecotype. So it gives you kind of a sense for just how much is going on a native seed farm in order to be able to think about how to maintain those local genetics and how to maximize yields and the quality of the material that's produced. So the main thing, of course, you want to minimize any potential cross-contamination. With these various ecotypes that you work so hard at producing, you want to make sure that you're not having hybridization. And so a distance between the crops is the kind of the primary thing that you look at with that, and that distance can vary depending upon if it's a selfing or a crossing species. It can also, there's also some data that we follow and some papers. The California Crop Improvement Association also has some information on distances that we follow as part of that as well. But we look at other things as well. We look at prevailing winds. One of the things about Hedgerow Farms is all of our fields, like I mentioned, are bisected by hedgerows. Those hedgerows provide a great place to capture pollen and to divert pollinating insects. So we take that into consideration in field placement. Another thing we look at too is the crop history. We don't, for example, want to put an ecotype of one species on top of another species in that same field, because obviously you'll have some material coming up from the year before. But we also look at the cropping history in terms of like trying to maximize the yields that are present. So one of the things with the crop history is we always try to put a grass over a forb and a forb over a grass. I guess on my screen, I see that we're back to the agenda. Yeah. Is that what everybody else sees?
Whoops, sorry about that. That's my bad.
Okay, no problem. All
Let
right.
me do a quick reset here. You can get a glass of water. Perfect.
All right, sounds good.
Let's see. My Acrobat does not want to play along right now. So let's try that again. Thanks for your patience, all. We want, let's try again. Okay. Oh. I'm so sorry. My computer is misbehaving. Let's get this thing going again. Here we go. This one, share.
Okay.
Let me get to your slide.
Yep.
How about that?
Backup one.
Backup one.
There you go. Yeah. Okay.
Sorry about that. Thanks for your patience, all.
No worries. Okay, so like one of the things also is the crop. We talked a little bit about the cropping history. So one of the things that we try to do is we try to plant a grass over a forb or a forb over a grass. And the idea with that is twofold. One is it tends to increase the production when we do that. But it also, it provides us with the ability to use grass-specific herbicides or forb-specific herbicides in that field. Matthew was talking about the importance of weed control in his last presentation. It's really an essential part of producing high-quality seed. And I'll talk about that in further detail, but so that's another advantage to being able to use grasses over forbs and forbs over grasses. Also time. So one of the things that we think about a little bit here is, you know, if we have the ability to grow out a certain species in 1 year and not several ecotypes in the same year, it basically eliminates the potential for cross-contamination. So if we can get, for example, enough California poppy to last us for 3 years, that means that we can potentially avoid having to do multiple ecotypes in the same year. And then one of the thing is, another thing to consider also is the size of the fields. So we have some targets that we're trying to meet each year. And so we're, you know, it might be 2 acres of a given species or a half an acre or 5 acres. And so we have to, amongst all of these other constraints, figure out how to place these fields amongst the various sizes that we're trying to target. So it adds a lot of sort of complications. Another thing that we look at is the weed history. Certain fields can have problematic weeds, and sometimes those weeds have produced seed that's very similar in size or shape or weight from our target seed. You know, the crop that we're growing, and it becomes very difficult to try to clean that material out. So we think about that. So if we know that one particular weed is a problem and we know about that weed size of that weed seed, we try not to plant a similarly sized seed in that particular field. Okay, next slide. Okay, so planting native ecotypes. Most of the time out here in Northern California, we plant in the fall. We do so whenever we can via seed drill. And kind of one of the things that we do at Hedgerow Farms is we plant on beds as opposed to in the flat. And so we had to have a custom-made seed drill for that. And as the story goes, John Anderson was at a conference and he was talking to Jim Truax about like, hey, you know, we plant on beds. How do we possibly get a driller that'll work with that? And basically, John sketched out on an envelope the design for this particular seed drill that Jim Truax then built for John as custom made for Hedgerow Farms. And so that's that same seed drill that we use today. Anyway, but sometimes, as I mentioned, stock seed is very limited. And then when there's limited stock seed, we actually have to grow that material out into plugs first. And then we put the plugs out into the field. You know, that's not we would prefer to go direct seed because it's cheaper and you end up getting higher yields. But a lot of times, again, you're limited by the amount of stock seed that's available. You know, most of the time we plant in the fall, but sometimes we do plant in the spring. There are some wildflower species that can produce fairly well. When necessary, or if we have plug material, that can go in the spring as well. But most of the time, again, we try to direct seed in the fall. Next slide. Okay, so weed control is absolutely essential to produce high quality seed. And so we use lots and lots of different techniques to try to control the weeds. One of the things that we do prior to the fall planting is we irrigate up the fields. If you look at the sort of that photo on the upper left, you can see the guys there with a wheel line, and we irrigate up the fields, try and get the weeds to germinate first, and then we control the weeds before we plant. That's a very effective way to sort of minimize the amount of weeds that are present. But we also use lots of other tools. There are some of our crops that we burn. If you look at the lower left photo, you can see a cultivator there. You can see that it's cultivating the areas between the crops, between the rows, and also in the furrows. We also have to bring in a lot of contract hoe crews, a very expensive process, but absolutely necessary to keep the weeds out of the fields. Then, of course, as I mentioned before, we use various combinations of herbicides to control the material. So it's basically weed control is probably the biggest component for us in terms of growing out high quality seed. Next slide. So one of the most technical considerations when you're growing out seed, native seed, is calling ripeness. Like, what is the best time to be able to harvest that material? So one of the things that is, if you harvest that seed too early, it's going to have very low germination. If you harvest that seed too late, it's going to shatter and your yields are going to go way down. So it's really kind of a delicate balance. And also you have to have some familiarity with the various ecotypes. We have, there are different ecotypes that end up ripening at different times. Some ecotypes will hold on to the seed, so you don't have to be so precise. Other ecotypes, the moment that seed is ripe, it will shatter. So sort of getting to know the material that you grow out, those ecotypes, is really essential for timing that harvest window so you can really maximize the yields and the quality of the material. Next slide. So the harvest techniques, they vary quite a bit. We try to use a flail vac. If you look at the photo in the bottom left, when we can, it's basically an implement that's attached to a tractor that acts like a vacuum. It essentially it pulls the ripe seed off of the crop and leaves the unripe seed behind. So that gives the ability to go in on multiple occasions to try and harvest the seed using that flail vac. So for example, you can harvest the seed that's ripe early, middle, and late. And so you get a better representation of the genetics, and in theory, you probably get a little bit more of a harvest out of it, a little more yield. But a lot of times, you know, the flail vac won't work, so we have to go and use a swather. And if you look at the photo on the bottom right, it's a piece of equipment that cuts the material a few inches above the ground. Next slide. And it creates a windrow. So if you look at the photo in the upper left there, you can see the swather cutting a field of Festuca microstachys. It's leaving a windrow behind. After that material is cut, it's allowed to dry. And then it's picked up by a combine. So you can see the combine picking up the material there on the bottom right. Next slide. No, but you know, the way you harvest can be very different. For example, milkweed, the pods, they ripen differentially. They have this indeterminate ripening. And so you can't go and basically go in and harvest that material all at once. You'll get a very, very small yield. So with milkweed, for example, we actually have to harvest that material by hand. And it can take more than a month to harvest a field by going out every couple of days to get that material. But it's really necessary if you want to have a decent yield. And so that's sort of, you know, it's one of the reasons why milkweed is so expensive, is because it's so labor intensive to produce that material. Next slide. You know, but the thing with the growing out natives is you have to be innovative, and oftentimes you're asked to grow new things, and with that you learn as you go. And so over the last few years, we've been growing out tar plants. Really hot pollinator plants. They tend to flower late in the season, so they provide those important late season pollinated resources. They're also sticky plants, and so what they end up doing is you get a lot of insects that get stuck to them. That the carrion from those insects then provide food for predator insects. So you get this sort of beneficial insect benefit by tar plants. So they're really becoming people realize how important they are in terms of high quality habitat restoration. So anyway, in the process of starting to grow out tar plants, we tried to use the normal sort of routine where we would cut the material with our swather. And we found that swather was getting gummed up because of the resins associated with these tar plants. And so instead, we had to use a sidearm mower, basically a sickle bar, to be able to cut the material. And then we used tines that were attached to like a fork attached to a tractor, and put that material into large piles on tarps to allow it to dry. And then with that, we had to feed that material into the combine. So it just kind of gives you a sort of a sense for how with each individual species, and as you try new things, you have to adapt and basically learn as you go, and use that lesson learned the next time you grow that material out. Next slide. So an important part of the process also is making sure that you're properly curing and drying the material. You want to make sure that the moisture content of that seed is less than 10%. If it's above 10%, the germination is going to fall off relatively quickly. So you want to make sure that, again, you're down to maybe around 8-ish%, something like that, before you go and go through the cleaning process. So if you look at the picture below, like if you're looking at a very large pile of seed like that, in order to properly dry that seed, you actually have to turn it. And so we actually have our guys go out there with shovels and turn that material on a regular basis to get even drying across the board before we move that into the cleaning mill for cleaning. Next slide. And so seed cleaning is also an essential part of the process of growing out native seed. You know, it's really important that you grow this high quality seed that has minimal amounts of weed and chaff. So if you look at the picture on the upper left, that's a combine dumping the material into a dump cart. Now, a combine actually is a remarkable piece of equipment. That technology has been around for more than 150 years, but it really does a great job of initially cleaning that material. It really separates that seed from the chaff. So you actually get a lot of the bulk cleaning is done through the combine. But then you'll take that material, put it out on the tarp to dry, like I was describing earlier. And when that material is dry, then we bring it into the cleaning mill. And at Hedgerow Farms, we generally use 3 different machines to clean our seed. If you look at the machine on the upper right, it's a clipper, it's a cleaning machine. It's the primary cleaning machine that starts the process. It has a series of agitating screens that separates a lot of the material out, your target seed from everything else. If you look at the bottom left, those are indents. They're basically these dimpled cylinders that, as the cylinder spins, based upon the size of the dimple and the material that's in it, and you have to set it based on your target crop. Basically, the target material will fall out in one location, and everything else will fall out in a different location. So it's a way of separating out things by size. And then finally, it goes through what's called a gravity table, and that's the picture on the bottom right. That gravity table, it has blowers and agitators, and essentially what it does is it separates out the heavy seed from the light seed. The heavy seed is the seed that has high germination. The light seed is the material that has low germination. So that's the usual process. But there are lots of different variations with different species, et cetera. But generally speaking, that's kind of how we clean our seed at Hedgerow Farms. Next slide. So after the material has been cleaned, it has to be tested. Basically, as part of that testing, you look at the purity of the seed, and that's broken out by the percent of other crop, the percent of weeds, and also you look at the germination or the viability of the seed. So that's a really important part of it. When you're selling seed commercially, you have to have a seed that's within 15-month test in California. So it's absolutely a part of the process. But a really important part of the process also is to make sure that you're properly sampling that seed. So you're getting a representative sample of the material that's produced in that given lot. And so the California Crop Improvement Association, they do a workshop for seed cleaners, basically, that certifies them as certified seed conditioners. And with that, they teach how to properly sample that material. So again, you end up with a representative sample of the seeds. Next slide. Seed storage is also a really important part of the process, right? Seed, of course, is living material. You know, its germination falls off through time. So you want to be able to have that seed, keep that germination as long as possible. So it's still viable and will still work well on your restoration projects. It's best to store seed in an insulated warehouse to take those high temperatures off. You know, the insulation really does a good job of taking off several degrees from the outside temperatures. At Hedgerow Farms, our material is packaged in breathable polyethylene bags, you know, which helps with keeping the seed relatively dry. And at the end of the day, what you're trying to do is you're trying to minimize the heat and the moisture, and you're trying to protect it from rodents and insects. And so there's kind of a general rule. You want to make sure that the heat and the temperature in Fahrenheit and the percent moisture content together doesn't exceed 100. That's kind of the goal to maximize the viability of the seed. And the shelf life of the seed can vary considerably. Hard-coated species like lupins, sometimes they can remain relatively viable for a decade. Or perhaps longer. Other things can only be viable for a year or two. Native grasses, their viability is kind of sort of in the 3 to 6 year range. Some species can go a little bit longer, so it just sort of depends. And part of the process too is that you have to retest that seed, and the retesting requirements are either 8 months, 12 months, or 15 months, depending upon who is purchasing the seed. So if you're selling the seed to another dealer, it's 8 months. Here in California, we have the transportation agency called Caltrans. For their projects, the tests have to be within 12 months. And then for everyone else, it has to be within 15 months. Next slide. So this is going to move a little bit into tomorrow's discussion, but I think it's important just for folks to realize that in order to sell the seed, to bring the seed to market, you have to be able to convey that information in a very user-friendly manner. And we have this, we have a sortable database on our webpage at Hedgerow Farms. It really provides some excellent information. Next slide. So you can see in here, this is just a screenshot of Stipropulchra, came off of our sortable database. With that, just put in Stipropulchra and it provided all of the ecotypes that's available in Stipropulchra. So if you're a restoration designer and you want to figure out what seed is potentially commercially available, it's really great to have this resource available so you can get a sense for, you know, what you can design. Because at the end of the day, the last thing you want to do as a restoration designer is to put in seed requirements that aren't commercially available, because that'll then put the project into change orders, which is not a good process. So provides a really powerful tool in terms of like at least getting a sense for commercial availability. Next slide. And then, so here's just another screenshot. This is sorted by county. Here we are in Yolo County, so I just chose Yolo County for that. So gives you a sense for like all of the different species that are available in Yolo County. So depending upon your particular project, maybe species is more important, or maybe ecotype or location is more important. So gives you a couple of really good tools with that. Next slide. And then we also have an ecotypes map that shows basically, if you're on our webpage and you hover over this map, over each dot, it'll give you the species and the particular ecotype. So it gives you a sense for where things are located geographically, which can be a really sort of useful tool when you're designing your habitat restoration projects. Next slide. Okay, I kind of mentioned earlier, contract growth, seed increases. That's a really important part of many native seed growers' business. A lot of times, the seed that the client wants is it'll have very specific genetic requirements, and the seed that we have available won't necessarily meet that. And so what they do is they go and harvest the stock seed from the wild. They provide us with that stock seed. We oftentimes clean that a little bit more than it's been cleaned. And then we send that out for test. And then based upon the number of live seeds that are present within that stock seed, we decide which way we'll be able to grow that out, whether that be directly seeded or into plugs, as I described before. And what we do with these contract grows is we really, we do our best. You know, we plant and irrigate and fertilize and control weeds and really try to produce high quality plant material, seed material that's, you know, with the maximum yields that are possible. Usually we have a half-acre minimum for that because there's an economy of scale that's associated with growing out this material. And then with that, all the seed that we produce is provided to the client. So it's kind of on an acre basis, basically. Next slide. And then, you know, oftentimes the clients will allow us to keep the seed. And so that keeps some of the seed or the field in, and that allows us then to bring new species and new ecotypes to market. It's one of the ways that we do that. So it's a great opportunity for that. You know, in recent years, we've been growing out some plant material, some seeds for to help mitigate impacts to special status plant species. That's been kind of happened on a few projects. It's been pretty interesting growing out these rare plants for mitigation purposes. And here at Hedgerow Farms, we currently have about 25 different items under contract. So it's a pretty diverse array of different species from a large number of different clients. Next slide. And then finally, I just wanted to mention that native grass straw is a great byproduct of growing out native grass seed. It really provides some excellent erosion control. You know, oftentimes you get a little bit of native seed with that. So it's not enough native seed to get you a nice stand of native grasses, but it certainly helps. And it's certainly better than say using wheat straw or something along those lines. So anyway, I think that's it. Next slide on that, I guess. One thing is that during the panel discussion, Jeff Queter, our farm manager, he's going to join us. He'll be able to answer any nitty-gritty questions that folks might have on how we actually grow out our seed. So that's it. Thanks so much. And thanks, Liz, for saving the day.
Yeah, thanks, Liz. Thanks so much, Pat. That was incredible. I really appreciate you providing that insight on the industry for us. So we're a little ahead of schedule by about 10 minutes, everyone. I think what we'll go ahead and do is maybe ask a few questions for the first two speakers here. And then ultimately we'll take that 5-minute break and then we'll resume the agenda according to schedule. So Megan, go ahead and take it away.
All right, great. Thanks, Pat and Matt, for the first presentations. So I think everyone, Liz should be turning on everybody's ability to mute and unmute yourself, and you can turn on your camera. Again, at the bottom of the screen, there's a panel where you can see in the very left corner, the mute and video. So you guys can go ahead and do that. If I have one question that I'm going to read off for Matt from Corrine from BLM. If you want to ask a question with audio, please raise your hand and then I'll call upon you so we can have a little bit of order. I haven't moderated a panel virtually with 107 people before, so we're going to see how it goes. But thank you for being patient with us. So Corrine's question for Matt, I don't know if you saw it, but I'll read it for you. It says, do you think collecting native seed in the field and then applying it directly to restoration sites the very next season can be just as effective as investing the 5 years it takes to do the seed increase on farms?
Certainly, yeah, why not? That's just merely a question of scale. So if you've ever tried to, let's pick one like picking lupin. Let's get some silky lupin and go collect it and put it right back on our field. And I want to put it down at, let's just do 1 pound an acre. Well, if you have to go collect that many pounds of it and then take it back and put it on the ground, how many acres are you going to cover? And this is the difficulty. Obviously, you can collect, go right back, makes great sense. Certain species, as balsam root, you should not grow it, probably not. Most Solomatiums, and unless you intend to live longer than the rest of us, you probably should not grow it. You should just go collect it. And so it works great. Is it scalable? Are we making landscape level effects? Not likely, not likely, unless you have a whole lot of hands. You could substitute with population, but unlikely.
Great, thanks, Matt. I know that April had a question about the database, so Jesse put that in the chat as well. So appreciate that.
Oh, you want me to put that in chat? Sure. No, you just go to hedgerowfarms.com and it's a link in there. So, but yeah, I'll answer that. So
great, thanks, Pat. And I was wondering, maybe before you do that, if you have a favorite species to grow of native seed.
Oh, favorite species. I kind of favor the wildflowers. They're just so spectacular to grow. We have a field of Chrysanthemums that's in flower right now, and it's just spectacular. It's a tidy tips. It's really fragrant. It looks really good. So I would say that I like the wildflowers in general, and I'd say right now my favorite's that Chrysanthemums. Yeah.
Awesome. Thanks, Pat. Brian Irish, I see your hand is up. You want to ask your question?
Yeah, good morning. Thanks, Pat and Matthew. I have a question for both of you all. So when you have these ecotypes and they've been collected on the landscape, do you store those original populations, those original ecotypes long-term, or do you just go back to that same population in a future increase? Hopefully that question was understandable.
Brian, yes.
Go ahead, Matt.
Put it in the stock seed room and it stays there for a while. Now, the question is what did we start with? I got 37 grams. Well, then guess what? There's no original population. I used it to try to grow what needed to happen. There's a way that happens there. Again, it's about generations. Sometimes we always will take, first gen material and put it back in the seed room. How much genetic drift is occurring? That's a great discussion, and it's different, and it changes per species. It changes on the growing season. and what that particular situation was. But yeah, we do keep it in there. We also do, for certain SIs, we do recollect from the site. Go back 15, 20 years later, make a fresh collection and refresh that genetics, especially when we've reached sort of the generational limit on our SI certifications.
Yeah, so
Great, thanks, Matt.
so at Hedgerow Farms, yeah, we also try to maintain the material. Usually what we do is usually isn't a lot of the G0 seed that's available in addition to what we put in the ground, but we certainly do save that. But most of the time we'll take that generation 1 seed and we rent out a pallet and a climate controlled storage pallet there where we keep that stock seed for the future.
Great, thanks, Pat. Brian, did that answer your question?
Yeah, I put just a chat comment. I wondered if you ever went back to a recollection site and not found the population. It's gone. I mean, that's the part of the reason I'm asking the question is because I'm with the National Plant Germplasm System that has 20 or so thousand collections made by the Seeds of Success program. And the idea is that we're the fail-safe. We have the original population, small quantities of seed, and if they're gone in the landscape, we might be the only source of those original seed collection populations.
Pat?
I don't, I'm not aware of any times that we've gone back and not found the populations, but, Hedgerow Farms has been around for a long time, so I wouldn't be surprised if some of the original material, some of these populations have linked out. We see that, things do vary, right, with climate and disturbance, and there's a lot of fire and things like that here in California. So I wouldn't be surprised if some of these original populations are gone. So, but that's just speculation. Yeah.
We have, I mean, there are populations that maybe much reduced would be the thing. We've gone back and what was a whole hillside is now a whole vineyard and winery. And you're like, oh, well, not that I have a problem with the vineyard and winery, but I do have a problem with the fact that, holy crap, that was like one of the best little flower places you could get that. And so you couldn't put a winery anywhere else. It had to be right there. Well, then there's a few species missing that way, but it hasn't been a huge problem for us.
Great, thanks. Ed, I saw you had your hand up. Do you have a question? You're muted, Ed.
I think in the short term, there's too much nuance for me to generalize on our impact of removing a seed crop 1 year versus another. Sometimes we go back and they've completely disappeared and we think it's a 1 year phenomena or 2 years. And then 5 years down the road, there's a bumper crop there again. And so there's a lot of resilience there. And I just know for sure that I don't want us to be stereotyped as removing all the seed and destroying a population, especially when it comes to perennials, indeterminate species, that sort. The other question I had was for Matt, was related to lomatiums. We had a phenomenal showing of a native lomatium that we did not seed after a fire a year ago. And I think it came from seed, not roots that had been in the ground, because it had been a matured pinyon juniper sage stand for eons. And so I was assuming that lomatiums could be a good candidate for our nurse crop collection. And anytime we can get a good native nurse crop, we're after those crops. But you commented that you had troubles with lomatium, trying to get them to, it's like ginseng or something, a long-term root development or something. Are there both in the lomatium group, I suppose? Perennial, annual?
I haven't run into an annual one. We do see them have a faster perennial life than others. Some will, in year 2, put up some flower. Some year 4 or 5. And you sit there waiting and waiting.
Yeah.
And what you also will see too, at least in our experience, and obviously, Pacific Northwest, Intermountain West, it's different than other areas. But the lomatiums we work with, they tend to build as they go. As that root gains energy, you see more flowers and you see more seed set and better seed set. And so it takes some physiological energy in the plant to say, oh, I have the capacity to have successful sexual reproduction, but I need that capacity in place. Probably not all of them, but it definitely has been, at least with none of the lomations we've worked with.
I think we witnessed an event where we went from seed germination post-fire to full-blown flowering plants and seed production in 1 year. And
It
that,
could be. There are
Yeah.
triggers. I'm always amazed. I mean,
Yeah.
hawksbeard, there's one that, wow, what the heck triggered that, you know? And there isn't actually, I mean, I don't have the magic answer, but I saw it on the hill, so something did.
yeah. Well, thanks, Matt. Thanks, Pat.
Thanks. We may have time for one quick question, and then we're gonna go to a poll question and a 5-minute break. Is there anybody else that has a quick question? And just so you know, we will still have our panel discussion. So Matt and Pat will be back to facilitate other questions later on too. This isn't your only chance. All right, I think with that, then we'll put up a poll question and we're gonna take a 5-minute break. So we'll be back we'll do a 4-minute break if we can. So we can kind of stay somewhat on schedule. So we'll be back at 10:20. Thank you guys. Really presentations this morning. All right. Thanks for filling out our poll questions. We really appreciate it. It helps give not only us within the Nevada Native Seed Partnership some good information, but it also helps our speakers get a better understanding of our audience. So again, if you want to turn on your camera, you can. The microphones will be muted until we get done with the rest of the presentations and move into the panel discussion. Again, if you have questions during any of the presentations, please feel free to put them in the chat or save them and raise your hand, and then we'll do that, get those answered during the moderated portion of the meeting. And I'll back to you, Russ.
All right, well, welcome back, everyone. Next up on the agenda is going to be Robbie Hennis of Southwest Seed. So Robbie, if you want to go ahead and get prepped on your end, see if we can get that screen shared, and we'll start your presentation. And then I'll give you a quick intro. All right. So Robbie grew up outside Dolores, Colorado on a potato farm located near the Dudden Hot Springs. That probably set the stage for a continuing interest in agriculture. She ended up in Colorado helping to manage and run the processing and management of seed distribution and sales for Southwest Seed. All right, Robbie, take it away.
All right, well, it's nice to be here and hearing other presentations and participating with you all. I really want to thank Matthew and Patrick. I think they set the stage for me and probably stole a little bit of my thunder also. So my objective would be to give you a little bit of background about our company and share some insights into the challenges and opportunities that we face. So first of all, the biggest thing is that we are not in California or Washington and Oregon or Nevada. We're way over in Colorado, which is a different growing environment. Probably many of you are a little bit more familiar with the Great Basin Plateau area and ecotypes and everything. And we identify more with the Colorado Plateau. And I saw Adrian as one of the participants here. So a couple of fist bumps to you, Adrian. So I'd like, I guess, to start with a preface that our area down, you can see that blue area pointing to our general area down in the southwest corner. We're in a very arid part of the country and Colorado, identify more with the deserts of New Mexico and Arizona, as if anything. Perhaps that is a really good piece of information to hold in the back of your mind as I talk about some of our constraints, because moisture and managing for moisture is one of the biggest things. Weeds are right up there too. Those two things kind of go hand in hand and give you equal headaches on both sides of the equation. We are a fully integrated farm and sales company focused on natives. So by that, I mean, we have a 750 acre farm out near Pleasant View, but we also sell and provide seed from other companies also to our area. The nearest seed company like ourselves to us would be people up in Denver, out of Salt Lake City, a couple of seed growing cooperatives down in New Mexico and Arizona, but nobody else that is kind of doing what we do in quite a wide range there. So we kind of see ourselves as a full spectrum farm. We were established approximately 1975. The date is open for debate because my family moved to this area when I was 5, and Dad was a geologist working in uranium exploration. And that was right, well, in the late 60s, early 70s is when uranium went bust. So he moved here just in time to lose his job and try and figure out if he was still going to be a geologist or if he was going to change careers. And so he kind of very willingly, but very ignorantly wandered into farming and agriculture. We started out in potatoes and up way high in the mountains, and our growing season, if we were lucky, was about 2 months long. Didn't really work very well, so started migrating down out of the mountains and also looking for other crops that might be a good fit. About that time is when the Conservation Reserve Program came along, and Dad was creative and fortunate to kind of fall into that, meet some people that were very helpful in helping him understand that industry and willing to share their experience as he experimented with different crops that would work in our area. A couple of other things I want you to note is you don't see any population dots very close to where that arrow is. We are very rural. That's a great thing in many ways. We don't have a lot of contamination, obviously, from other farms around us. We also don't have great transportation. We don't have a lot of other resources that maybe make some of other seed companies a little bit more viable or a little bit more exposed to possibilities and opportunities. I mentioned already that we are considered a part of the Colorado Plateau, and we're considered a part of the Uncompahgre Plateau, a smaller part of the Colorado Plateau. So that gives us, that's kind of our niche. That's what, when people are looking for specialty seeds, that's one of the things that we have going for us is our climate, our soils, our environment, but that part of that ecosystem. We are a family business. So my parents started this business, as I said, around 1975, something like that. My high school years were filled with doing wildland collections and then testing them to see, does this grow? What is it, what does it do? How does it handle agronomically? Because a lot of things that are hand collected don't necessarily play out as you try and turn them into some kind of production crop. So as I said, started out in potatoes, really, as we were learning from that and realizing we weren't potato farmers, we had to figure out what to do, consult the experts. We did try some more grain type crops and some more forage grasses and things, but the cost of our water out here is so expensive that it's really prohibitive in a lot of those industries compared to what people can do when they have more moisture in their areas. So we consulted more experts. That is my mother. One of the side hobbies was experimenting with beer brewing for a while there. And we continued to consult the experts and still can't fully decide what the right answer was, but we did finally stumble into growing native grasses and wildflowers. We started out with just a few crops and learning what to do. This is my father, and he is trying to encourage growth of things that we don't really understand. Once you put that seed in the ground, there are a lot of factors that nobody can really control. We think we know a lot, we do a lot of the right things, but sometimes it's just not there. So Southwest Seed grows approximately 30 to 40 different species each year. We follow a slightly different model from what we heard from both Matthew and Patrick, because we grow some varietals, some things that have been tested and released, and those are sort of our bread and butter crops. The local ecotypes are an add-on to our main production, partly because there aren't as many agencies in our area that do use as many local ecotypes as perhaps there are in some of the other states. So this is by no means a complete list, but this might give you a little bit of an idea of kind of how we approach it and what we grow. We are very good at some warm season grasses, blue grommas, side oats gromma, little blue stem, and we just took out the galleta last fall, the year of a lot of fires and droughts that hit a lot of plant or production fields very hard. And so now when we would be supplying galleta all over the place, we're going to run out this year. And that's heartbreaking, but that is a part of farming, is always making those decisions, trying to use that crazy 8-ball to figure out what you really need. Some of our cool season grasses include Western wheatgrass, slender wheatgrass, Arizona fescue, Basin wild rye. Those are some of the species that we can do very well with here. And I'm going to back up and just mention more about that water, because our water bill in an average year is well more than $50,000 a year. So the species that we choose, some can be high yield and low value, but we do need to find crops that are of a higher value just to pay that water bill, as well as everything else, all those pieces of equipment, all of the cleaning stages and equipment that is needed. There's a lot of expenses involved in native production, period. The forbs, we're pretty good at farming some of the penstemons, Lewis flax, Utah sweet vetch. I don't know if everybody got to see our biography, but my brother, who is the farmer side of our operation, has this belief system that you can see our Utah sweet veg fields from the space station when it flies over. I do know that he's also encouraged some of the passenger planes going around to pull a U-turn to come back and check out his Utah sweet veg field. He's rather proud of it. Some of the other things, and these are more of our specialty crops, things that we have either been able to collect and grow out ourselves from locally, or that somebody has worked with us as a contract crop and we have been really successful with. So some of those might include mutton grass, coyote tobacco, sago lily, Thurber fescue, mountain muley, and many others. And then one other piece of this is we've been talking about doing contracts and specific grow outs for different people. Those come to us from all different parts of the seeding world. For us locally, Mesa Verde National Park has done some work with us, and like Patrick showed, the bales of native grass straw, we use a lot of ours in sale to Mesa Verde. That way they are getting more bang for the buck. They're not putting wheat, oats, barley, something like that out when they're doing seeding projects, and they are getting some more of those native grass seeds in their mulching. So that's a really important secondary piece of our business. We did a lot of work with our local Tres Rios BLM National Forest Service combined office. They were doing some work trying to come up with species for road closures. And one of the things that they really want to do is disguise old roads as quickly as possible so that they're not a temptation for people to continue using. And so we did a lot of experimentation with little hand collections that they had done partly through SOS and just locally, for this project. We've done several grow outs or attempted grow outs with Colorado Parks and Wildlife. And we did an IDIQ with the White River National Forest. And there have been many others throughout the years, but those are just a couple of examples of kind of the collaborations and the things that we will do with people. So my list isn't quite as extensive or nearly as pretty as Patrick's, but I do want to go through some of the considerations that we go through when we're talking to people about doing a grow out. And for us, we're a little bit more resistant to too many grow outs and too many local ecotype productions, partly because, as you'll see coming up, we're not all that good at it. And I'd love to know from Matthew and Patrick and others if we are just not as good of farmers as we like to brag we are, or if there are a lot of failures for other people also. So on-farm considerations would include that time and land commitment. And you've already been seeing a lot of that. It takes us minimum 2 years to get a field established. I think our growing season is a little shorter than some other places. And so some of them can get a field established in 1 year. For us, it's almost always a 2-year commitment unless we're trying to grow an annual. So that is a large time commitment just to get something growing, to the point where it may be able to produce something, and a large land commitment. And then when you add in all of those factors about isolation, et cetera, this is not just a one-off choice and a one-off commitment. It's going to have impacts on everything else we can choose around it for quite a while to come. Good seed. Good seed goes without saying, but that's not always easy to get. We have lost contracts because the contract seed had a contaminant, had some kind of a noxious weed in it, and there was no other seed to provide, so we didn't do that grow out. So that seed, getting good seed is very important. We've gotten seed that had been stored improperly and probably needed to be fumigated in some way. And so it looked beautiful, but it had all been insect damage. So again, we didn't have any seed that we could grow out. And then getting enough seed to meet whatever the grow out requirement is. So good seed is a pretty big deal. Another problem is, of course, when that seed is ready to be harvested versus when we're ready to plant it. And those two can miss pretty badly. And so then you're set back a whole year, especially if it does need to be a fall planting like we're typically prone to do. Right mojo. What do I mean by that? especially here in the arid Southwest, but I think in a lot of places, there are good growing years and there are not good growing years. And it may be species specific, and it may just be the rains came at the right time. Everything is doing what it should do and what we really want to see. But we don't get that right mojo very often in our area. We say 1 in every 4 years, hopefully is a pretty good growing year. And so sometimes best laid plans, they just don't work. We plant, we've done everything we know to do, and it's an utter failure. Maybe it was the seed, maybe it was the time we planted. We can't always tell what went wrong. Watering regimes for us is another biggie, because we do have to irrigate everything. We do not get enough summertime moisture for any of our crops to really thrive. Comparative to other crops around here. So the alfalfa farmers and the bean farmers and other people like that, what we do is not nearly as water hungry as a lot of other crops. We're very fortunate in that, but we are growing crops starting in early May. Even in April, some of our perennials are coming back in, and we're harvesting from late May up through November sometimes. So we've got this huge growing period compared to a lot of other farmers. And so having water when we need it is a really important consideration. And that includes when our irrigation is turned on and when it's turned off, and working with our local irrigation company to make sure we've got the right pressure when we need it, et cetera. So, and we have some center pivots, so we can water much easier than things that are on side rolls, which requires a crew to move it every day, sometimes twice a day. So just the whole watering ability, which fields can get the best water, and when the watering needs of certain crops are going to interfere with other crops or new crops that we might need to be establishing. So that's a big piece of it. Isolation has already been brought up as a super important consideration. We certainly don't want to invest all this time and energy into something that all of a sudden is contaminated because it's too close to another crop that either cross hybridized or whatever else might happen. Each species growth pattern plays into all of this also. So warm season or cool season, when is it going to need to be harvested? What equipment is going to need to harvest it? How much floor space is it going to need in order to dry it down before we can box it up and put it in the warehouse for cleaning later on? So all of those growth patterns can play a huge role in it. Managing for weeds and other contaminants, Patrick went into that quite a bit, and that is one of the banes of our existence also. So one of the things that we're always looking at and thinking about is what can we put in, the similar, I think, to what Hedgerow Farms does, mixing grasses and then forbs. So changing the production of whatever has been going on in one field so that we've got a better job. We can do a better job of cleaning because we can't get all of the weeds out. That's a pipe dream in many situations. So managing for that, knowing what is already there and what weeds may be coming up, we will leave fields fallow for 2 and 3 years to manage for those weeds, because weeds here are super prolific. They are so well adapted to growing. Similarly, managing for insects and other critters that might be causing us problems. We have a great relationship with our local insecticide people, or our entomologists, there we go, our entomologists locally from CSU. And so they are a huge help in not only helping us manage insects that are causing us problems, but then also thinking about future possible problems that we might have. Perennial crops. So since we are mostly natives and mostly perennials, how long a crop is going to remain in the fields and how long there's going to be a market for it. So 2 very important considerations. We want good seed to be growing, and we want a good market for that seed. Since most of our production is not actually in a contract, so all the seed goes to the person or the outfit that gave us that contract, We want a market that is continuing, that is expanding, that is not so niche that if somebody doesn't get their budget the next year, then there's no market for that seed, especially since it takes us at least 2 years to get things going. And finally, as Patrick demonstrated so well, there's a lot of specialized equipment and knowledge to working with natives at all stages, from planting to harvest and cleaning. So let's see if I covered all of my thoughts. So I don't have nearly as many cool pictures of some of our cleaning equipment. We run 4 different cleaning operations based on the size of the crop, based on the characteristics of what is coming into us, how fluffy it is, how much chaff and things we have to get off, what different components we work into each of these cleaning lines so that we can get a crop that is as clean and as easy for seeding later on as possible. Let's see, I forgot to watch my time. I think I'm going to be running out pretty soon, but I'm going to keep pushing on. So this is my brother and the farmer pose, or it's good to be curious. And that's very true. If for everybody who is involved in these natives, being out, seeing what is growing, where it's growing, what its habitats are and adaptations, etc., is a really important piece of kind of understanding what we're doing when we're at the field level, or coming up with what things we can experiment with. Now, it's always good to throw a couple of pictures of flowers in if you do farm flowers, because they are pretty amazing. So this is the moving into the local ecotype or the contract grow out piece of what I want to talk about. As I said, as a strategy, Southwest Seed does focus a lot more on varieties for our bread and butter crops, but we do also work with local ecotypes and things that people are looking for specifically. And it's not always clear what a winner is going to look like. So this slide might help, especially people who are looking at getting into some kind of farming of natives, or who are buyers. And if you're a longtime buyer, this is intuitive from the very beginning, but the values of different crops. So the more specialized, or the more, if I say the more native, that doesn't really mean anything, but I think a lot of you will understand. There are a lot of species that have not been played with. They've not been tried to put into production in any way. Those are very hard. We don't really understand nearly as much about growing them. So those command, maybe you can see over in the, let's see, for me, it's the left-hand side. So maybe that's the right-hand side for you, where it says $80 plus per crop. Those are the real specialty crops. Oftentimes that they are worth every bit of that $80 or whatever the price is, because they are either very difficult to farm, or they have so many native adaptations to how they grow that we don't have the equipment, we don't have the timing, we don't have the manpower to collect every bit of seed that they have to bring that production cost down. If you're going into something like the small Burnett, Sandfoin, alfalfa, those are very inexpensive comparatively, but you also grow it at huge volumes. So this is just so kind of supposed to show you that the more esoteric the ecotype is that somebody is interested in, the more difficult it is to grow, the more expensive it's going to be. So we, a while ago, put together a table of all of the local ecotypes that we had tried, and we came up with this legend for it. I'm not going to run through everything for you today. It's not worth it. I want you to get a sense of, from our farming perspective, how frequently we ran into situations that were the bottom 2 of my legend here. We wore ourselves out trying to figure out how to grow this crop, and we don't know the secret. Or, well, we got a little bit of growth going, but certainly not enough to call it a production field or a production trial, and it's probably not going to make it. We get a few cheesy grins, we score, we won, you know, we've really got a good crop here, and it's got market potential. And then we've got these hairy examples. We think we've got a winner, but Perhaps we're still developing the market, or, we had one good year and we haven't figured out what happened that year that helped so much and we're not doing as well in future years. So I'm just going to show you a couple of slides to give you a sense of, in this one, 2 hairy examples, hey, maybe we've got something here, and 4 that we gave up, that it just wasn't working for us. And it's not just that the crop failed, it didn't start to grow. Perhaps it grew, but it didn't make seed production. Perhaps we got so many insects that it wasn't worth it. They just didn't, we couldn't collect any seeds off of it. There's a lot of reasons why we called it a failure and have moved on from that. Now I do want to highlight my nymph here, not in my field. And we saw Patrick, I think, with a slide with a milkweed in it and talking about hand collecting it and having to do it multiple times because it was indeterminate. And that's one of the reasons why it's so expensive. When we tried to leave it in the field long enough for it to be fully mature and use some kind of mechanical means for harvesting it, before we even got there, those pods broke open and sent milkweed seeds everywhere. So we now have milkweed contaminants across the rest of our farm. So other people may have come up with a way that they don't mind dealing with it, but we don't care to grow any more milkweeds on our farm. So on this slide, 1, not in my field, 2, we're underwater, or we gave up, and the 3rd one is another hairy one, a 6 weeks fescue. The 6 weeks fescue is going to be my final example as to one that we are still growing, and we've learned a lot about it. So we'll share some of that with you. So 6 weeks fescue is a great crop to experiment with because, as you can see from my map at the bottom, it grows in every state except Oregon. And I have to wonder what's wrong with Oregon, or what's wrong with the map maker who decided that Oregon couldn't grow 6 weeks fescue. I don't know the answer there. Maybe that's something we can solve at the end in the panel discussion. But it is a little annual, which makes it an excellent crop. A lot of times we do want some kind of a quick growing annual to put in a mix so that we've got a cover crop or a nurse crop going. It can be an early graze option. There are good reasons for having an early growing annual native. So here are some of the things that we have learned and that we would declare as a piece of our experience with 6 weeks fescue. We got this from the Colorado Plateau, local. It has been labeled as a cool season spring annual. Our experience is that it is a winter annual. And that's a huge difference because we need that seed in the ground and growing as we're moving into winter. It actually kind of acts very similar to cheatgrass in that category. So it is a cool season native in the fescue family. It's found in 47 states. I don't think Kauai has much of it either. It is a quick growing annual that can provide about 6 weeks of graze when there's good spring moisture. It does well in sandy loam soils on woodland and open slopes in quite an altitude range. It quickly makes use of spring rains to germinate and continue its growth. It's been studied for road closures. That was one of the reasons we got started in this. Now read this next line carefully. It can grow from 1 inch to 3 inches. The maximum height that we have seen is about 1 foot. This is a huge consideration. This is a reason why 6 weeks fescue is not our favorite. It's not the easiest thing to grow. We'll come back to that though. It is a recommended species for fire-prone situations. Because it provides limited fuel sources and is somewhat fire resistant. So that harvesting is a huge consideration for everyone who is doing grow outs. It's very hard to come up with ways to harvest. So our ideal crop for harvest is something that grows tall and upright. The seed is held in a bucket, so it's not indeterminate. It doesn't shatter and throw itself all over the ground. And it's not attractive to deer, elk, and other critters that might want to come in and eat everything that you've got. It's not very often that we find those, but if we get to have any say in what a species looks like, this is what it is. Anyhow, back to my 6 weeks fescue. It does well on disturbed sites. and it starts its growth in September and then puts on rapid spring growth. So those are some of the characteristics that we're working with in the 6 weeks fescue. Some of our lessons learned, that harvesting challenge because it is so short. We estimate we only get about 10% of the seed. That means 90% lands on the ground. We actually treat this field like a weed field and cultivate it several times before we've got what we think is going to be the production field for the next year. We cultivate it 2 to 3 times to kill weeds and the fescue so that we've got good production rates. We are experimenting with over-fertilization to get higher growth, and we're experimenting with companion crops, which might be why we see some fescue growing tall in sage, or maybe it's because cows graze it and they just don't get at it in the sage. But these are some things we're going to experiment with to see if we do a better job of the 6 weeks fescue. So it is something we've got, but we're going to kind of leave that field for a while and move on to desert needlegrass just because we failed at that. So we're going to try again, see if we can't make that one start working now. And a few more flowers, just again, because they're very beautiful. Harvest crews, weed crews, very important part of our operation. And I will wrap it up. I think I'm just a couple of minutes over, so I thank everybody for their time. I hope I was coherent and not going too fast. Thank you.
Hi, Robbie. Yeah, you were incredibly coherent. Thanks so much for all that information. That was incredibly insightful. Right on time. That was perfect. So what we'll go ahead and do here, guys, is we will switch it over to our next presenter, and then we'll run a poll question in the meantime. Quick last minute update to our agenda, just so everyone's aware. Dr. Clinton Schock with OSU, he was unable to join us today, but we do have a stand-in for him. He will be having Eric Fiber of Oregon State University's Malheur Experiment Station present on his behalf. So we'll go ahead and have Eric load up his screen in the background while we take about 1 minute to finish up this poll. All right, Eric, looking good. We can see your screen. Oh, just lost your presentation.
Let me, well, I can move it. I have 2 screens, so that's fine.
That works.
Then I gotta go,
You can hit slideshow at the top in the orange bar there, or you can.
yeah, I forgot how to do this again.
So on the orange bar at the very top, there you go. Perfect.
Okay, I guess I'm all set.
All right. So with that, I'll go ahead and introduce Eric. Eric Fiber operates as a senior faculty research assistant at the OSU Malheur Experiment Station. Eric has multiple years of experience working with nitrogen and irrigation management with an emphasis on drip irrigation. Eric performs research of onions, alfalfa seed, poplar trees, as well as alternative crops. All right, Eric, take it away, my friend.
Okay. So, yeah, in this presentation, I'll be talking about research that we did as part of the Great Basin Native Plant Selection and Increase Project. So, shoot, kind of lost here. Yeah, there we go. So our experiment station is located in Eastern Oregon on the border with Idaho. And we're about an hour away from Boise, Idaho. So we are at the north end of the Great Basin, and the vegetation in the Great Basin has been in need of restoration efforts because of invasive weeds, overgrazing, and also fire damage. The Great Basin area is an area of high desert with precipitation about 7 to 12 inches a year, mainly occurring over the winter. So summers are long and hot and dry. So the objective of the Great Basin Native Plant Project is to increase availability of plant material for restoration efforts. Now, our objective was to develop irrigation and other cultural practices so that growers could go ahead and grow these as a row crop and produce a seed. So these are just some pictures of native plants that we've been working with. Mainly they're, fords, non-woody perennials. Most of them are perennial. We did work with a few annuals and a couple of biennials. And they're all very different. They have different longevities. Everything, the penstemons usually only, the stand is only good for about 3 years, and then you have to replant. The buckwheats and the Lomatians, we've had them 14 years or more, the same stand, and they're still pretty vigorous. I don't know whether you want to do that as far as seed production goes for certification, but they can be long-lived. Anyhow, so when you try to grow these as a row crop, you have a whole bunch of different hurdles that can be a problem. But for our research, we decided to focus on mainly three areas: stand establishment, weed control, and irrigation management. So I'll first go to plant establishment. So most of these need that winter vernalization, so you want to plant them in the fall. So when we first started working with these, we did a little experiment, planted in the fall, where we actually planted the seed at depth, like you would an onion seed. And we had a lot of problems. Our soils are silt loam, and they're very susceptible to compaction or crusting. And then also you plant in the fall, and you've got months where that seed is sitting there, vulnerable to compaction, desiccation, et cetera. So when it came to spring, we had very poor emergence in whatever depth that we tried. So we needed to change strategies. So we came up with 5 factors that we thought we could test to improve emergence. So row cover is a white fabric that's porous to air and light and water, but you cover it with the ground with that fabric, and it protects the seed from desiccation and compaction. So we plant the seed on the surface, and then we cover it with a row cover. We also tried seed treatment with fungicides. And then we tried sawdust and sand, because what we observed that was happening in some of our fields with the native plants is that we got a lot of volunteers that came up right underneath the edge of the plants when they were covered by organic debris. We got very successful volunteers coming up. So we figured maybe covering the seed with sawdust might mimic that, and then sand might be also helpful to keep the seed in place. And then hydro seed mulch, we tested as an alternative to row cover, because row cover is very expensive. So we tried different combinations of these factors in 7 treatments, including a non-treated check that had just the seed placed on the soil surface and nothing else. So the seed was placed on the soil surface in the fall, and then we applied the different treatments. Here in the next picture, you can see us getting ready, planting in the fall by hand. Short plots. We planted a whole bunch of different species and then put the different treatments on. And then in the spring, came back and did emergence counts. So you can see here, we removed the row cover from the row cover treated plots. And it's interesting to compare where the row cover was, the soil looks more moist and also less compacted than just above where there was no row cover. So anyhow, we did the stand counts, and then we could compare the different systems or combinations of factors. Here you can see one of the forbs emerging in the spring. And you can see how our soil is susceptible to crusting the silt loam soil. So here, this table shows some of the results of emergence for the different treatments. And basically what we found is the most consistent factor that we tested was row cover. Row cover benefited all the species that we tried. It was the consistent factor that was good at improving emergence. The other, well, mulch, I need to mention, was not effective. There's no way mulch could replace row cover. It didn't work for us. Sawdust, seed treatment, and sand were variable. They worked for some species, didn't work for others. Seed treatment on occasion was detrimental, was negative for emergence for some species. So anyhow, that's the take-home message is row cover was the most consistent. So let's, oh yeah, these are some pictures of the stands later in the year of the little plots that we did for the emergence study and how it's possible to establish good stands with some of those treatments. Okay, let's go to weed control. So one of the problems with weed control with planting these native plants is that you plant them in the fall and you have a huge period, months when the seed is just sitting there, and weed seeds can also germinate and grow. So by the time spring comes, you're fighting all the weed seed with the native plants. And the problem is we don't have any herbicides that you can apply at planting. So you have to wait to establish the stand and then put the herbicides on. So we were looking at two types of herbicide, the soil active ones like Prowl and Outlook, and then the foliar active ones like Goal and Bucktrill. So we planted these native plants, a bunch of different species in the fall, and then came back in the spring. And after they had emerged, we started applying the different herbicide treatments and then observed, you know, visual damage, and then later got seed yield. Yes, I already mentioned that. Okay, and then this graph shows seed yield from a bunch of different treatments with these different herbicides. And the take-home message is that we found that the soil active herbicides Prowl and Outlook really work well. They if you put them on, apply them after the plants emerge, they are very effective in controlling the weeds and not damaging the native plants. Native plants are very tolerant to that. So that's something we do routinely in our native plant field, is apply Prowl and Outlook usually once a year in the fall, sometimes maybe again in the spring. But now the foliar active herbicides were more of a tricky situation because there's so many different forb species and they all react differently to the herbicides. So we found some successes with some species and not with others, but we had limited resources to you know, put into this research. So we didn't really develop a whole lot of conclusions from it, because you start getting into different rates and species, so it gets real complicated, but there is potential there. So I think now I'll go to irrigation management. So this is where we spent the most energy, is in irrigation management. And for this, we planted long strips of each species, the length of the field. We planted 4 rows of each. And then we put a drip tape in between every other plant row at 12-inch depth. This was like a permanent drip situation. We put it at 12-inch depth because we figured we would then keep the soil surface drier and not stimulate weed seed emergence or germination. And then after we put the drip tape, we cut the field up into 30-foot plots so that each could be irrigated differently with a different main line. So the irrigations were applied every 2 weeks, starting when the plants started to flower. This is a picture of sulfur buckwheat, one of our sulfur buckwheat strips. So our experimental design, when we had 3 treatments, a non-irrigated check, and then a treatment that was irrigated 1 inch of water per irrigation. And then the third one was irrigated at 2 inches of water per irrigation. And we gave them 4 irrigations every 2 weeks, starting when they started flowering. So we had the non-irrigated check that never got any irrigation the whole season. And then we had the middle rate, which got a total of 4 inches for the season. And then the highest irrigation rate got 8 inches for the season. So we did these treatments, and then we'd come and harvest the seed when the seed was ready from the middle 2 rows. When it took off the border effect from the edge rows. And this is a picture of our small plot combine harvesting sulfur buckwheat. So for a lot of these, we were able to use a plot combine to harvest the seed. And yeah, we had a total of 33 species that we've tested over the years. And because these are irrigated when they start flowering, we had a whole bunch of different irrigation zones. So you can see all these, a huge number of electric valves controlling the different zones in the field. And we used sand media filters to filter the water for the drip irrigation. So I'm going to talk about just 2 examples of the irrigation results. The first one is the prairie clovers, Dahlia ornata and Dahlia Searlsii. So this next slide shows the seed yield from the different amounts of water applied in 3 years. So in 2011, we actually had the highest seed yield with the non-irrigated check. In 2012, the highest seed yield was at about 6 inches of water applied. But in 2013, the highest seed yield was with the highest amount of water applied, 8 inches. So you can see that there's a lot of year-to-year variability in the responses to irrigation. So we decided we needed to look into precipitation because these plants are probably very sensitive to precipitation. So we added the amount of the previous spring, or the spring and previous winter and fall precipitation to the amount of water applied, and we reran these regressions, we ran the stats. And it's interesting because then we ended up finding that the ideal, or the amount of water to apply for maximum yield, was a lot more consistent from year to year. In this case, I believe it's about, I don't know, something around 6 inches. So we realized that we need to include the precipitation for some of these species when we determine how much water to apply. And the other example is Lomatium dissectum. Same kind of thing happened. If we just look at water applied, we have everything from a flat response, so no response to irrigation at the bottom. You see there's some years that way, to a quadratic response, or then to a linear positive. The highest amount of water gave you the highest seed yield. So again, here we added, in this case, spring precipitation to the amount of water applied, and we got much more consistent, from year to year consistent, ideal amount of water to apply. So anyway, that was interesting thing. We've done this with a lot of the species, and a lot of them are sensitive when we run the stats to precipitation. So it's interesting with these plants that we've had a whole range of responses where some of them do not respond at all to our irrigation, like the globe mallows. We never did get to respond to irrigation. The lomatiums usually are mostly respond pretty well to irrigation with increased yields. So there's a whole range of variability in how these respond. So I think I'm coming to the end here. So yeah, what we concluded, yeah, fall planting is definitely important. Direct seeding can be a problem, but we found some, methods that we can successfully establish stands. Commercial herbicides can be used after emergence to control weeds. And the seed yield responses varied by species and seasonal precipitation. And these are interesting plants. Only small amounts of water are required, especially when you compare them to conventional crops like onions or potatoes, which need 20 to 30 inches of water per season. These native plants require, 0 to 8 inches or so per season. So I just like to acknowledge our support for this research. And we have reports on all these native plants and all this research, multiple years on our website. So that's all available. Detailed information is on our website right there. So that's all I have. Thank you.
Thanks so much, Eric. That was fascinating information. I really appreciate that. So with that, I'd like to go ahead and thank all of our presenters this morning. I think we'll go ahead and we'll turn it over to the panel discussion now. Megan's going to go ahead and facilitate that for us. So let's go ahead and get it started, shall we?
Great. Thanks, Russ, and thanks to everybody that presented. And again, Liz has put the ability for everybody to mute and unmute themselves. So again, down at the bottom of your panel or bottom of your screen, there's a panel. On the bottom left is your mute and unmute and your video. You can either use the participants window or the reactions box to raise your hand. We're going to start with a couple of questions that were already put into the chat, and then we'll go to live questions. And Pat, can you introduce who is with you, just so everybody knows and can have questions for if they come up?
Sure. Yeah, this is Jeff Queter. He's the farm manager here at Hedgerow Farms. So he'll be able to answer nitty-gritty questions on farming.
Okay, great. Thanks, Pat. I appreciate it. So the first question is going to be for you, Robbie. Ed Kleiner had a question if you use active drying for your seeds.
Most of the time we do, but no, I'm going to take it back. No, we don't use active drying. We've got some adequate floor space just for things that we may have harvested a little bit early, but it's not typically our biggest need. And we'll oftentimes just run things through the cleaner if we know we've got some moisture problems. We'll do a quick dry run through the cleaner just to separate as much plant material out, which is one of our bigger problems.
Great, thanks, Robbie. And Eric, would you mind putting in the chat the website? Oh, Liz took care of it. Thanks, Liz. Appreciate that. Good. I'm going to move to Pat for these next questions. I can repeat them if you need, and I can also re-put them in the chat. They're from Kevin Gunnell, and he wanted to know if you think that there's room for more growers and producers, and what advantages and disadvantages to farm locations on the species that are being produced.
Yeah, no, I think there's more room for growers, certainly. I think in particular, growing seed of known genetic origin, the Ecotype seed, at least in California, that's really the direction that we're going in. And it's certainly impossible for individual growers to be able to cover the wide range of Ecotype needs, certainly as part of that. So what was the second part of the question?
What are the advantages or disadvantages to farm locations on the species that are being produced?
Yeah, so that was Robbie's, her presentation was very, very insightful. So a lot of the things that she's worrying about, we don't have to worry about that so much here in California. You know, it doesn't take 2 years normally for us to, for example, to produce a viable crop. You know, she talked about that quite a bit. We don't, here at Hedgerow Farms, we have 2 sources of water. Canal water when that's available, which is our preference because the quality is higher and it's cheaper. But we also have wells when it's not available, and having the ability to irrigate year round really makes a huge difference. Like this winter, it's been so dry in California, we've actually had to irrigate in the wintertime. So I would say there's definitely an advantage to where you grow out. But at the same time, you know, it depends upon where the seed is going to be provided, right? So you don't want to go to the Colorado Plateau to provide local ecotype seed for a seed that'll be used in California, right? Because it's gonna evolve and adapt to conditions in Colorado as opposed to in California. So there are advantages, but I think that has to be tempered by where that seed is actually going to be applied, at least if you're going to use it for habitat restoration.
Great, thanks, Pat. Robbie, I was going to ask you the same questions. Do you feel that there's room for more growers and farm location advantage, disadvantage?
Absolutely. Because there are so many different ecotypes of perhaps the same species, that is definitely room for growth, just because of isolation issues and things. And I do think that different areas have a different range of how many species might really play a big role in that area. I would say, though, that a lot of people who maybe have farmed or who are looking around for what can I do with this land that I purchased? Hey, I'll grow some native grasses. And it's not that easy. And so we get people coming along and saying, hey, you want us to grow something, either with the assumption that we'll do all the work, they just have the land, or that it's, you know, it's sort of like growing wheat. Maybe I got to learn a little bit, but the learning curve is much, much sharper than that. And the equipment needs are quite a bit different. So while I think that there is definitely room, I think it takes people who are serious about it and willing to work hard for some major failures for a little while before they start fine-tuning a couple of species that really work for them. And trying, unless you're like Matthew, where they have so specialized what they're doing that they can grow, I don't know how many different crops a year, you choose a couple that you have some kind of a competitive advantage at, and you play with that more than you try to cover all bases. Let's see, and I would say that your location does make a big difference. In our area, you know, you can move 2 miles, and I have 6 inches of snow in this last rain or snowstorm, and somebody else only has 2 inches of snow, you know, and that's just the grossest description of how there can be so much difference in the land that you're working with, as well as the soil types and things.
Great, thanks, Robbie. James had a question about irrigation requirements for each species and ecotype, and how do you change your irrigation? So Matt or Eric, do you want to take a stab at that one?
Yeah, we determined it based on seed yield. That's the main indication we have. We didn't measure any plant, you know, growth or anything of that sort. So I'm not sure if you're a grower and you don't know how much water it would need, how you determine that. But at least our research can be an initial, you know, if the plant you want we've worked with, that would help the initial start.
Great, thanks, Eric. Matt?
As far as getting seed, it is a species question. Some species are luxurious users. That's just, oh, you sent me more? I'll take more. Oh, you got more? I'll take more. And some will still hit their seed trigger just fine. Most species, though, need a stress point. They need to sit here and say, it's not so comfortable here. I can just be vegetative and live and have a good time. I need a stressor. Oh gosh, I better reproduce because my survival is now in question. So I need to do something. So the measurement of that, especially on these species, and you're saying by species or ecotype, You got to kind of feel it. You got to see what's happening. If you're looking at them and you're like, wow, well, everybody else should be flowering about this time. I mean, that's what it does on its local site. And so you use the local site as a baseline. You're like, huh, if they be flowering now, I mean, okay, we're keeping their feet a little wetter. When do you decide on that stress point, and when do you decide on seed fill? Because then here comes the other one is, once you think you have them stressed to make seed, give them the energy to make good seed, because plants have no problem making lots of bad seeds. They're like, oh yeah, I didn't mean to do that. That was not going to happen. You know, unwanted, out. And I wish I could say, oh yeah, do this. And it depends. Oh, did you get a hot 60-mile-an-hour wind yesterday? Well, nothing's going to pollinate. That's how that's going to happen. Doesn't matter what water you put on it. So.
Great, thank you. So we had another question in the chat. How do sprinklers versus flood or drip come into play, and how do you decide which method to use? Pat, I'll start with you, and then I'll let Robbie and Matt answer.
I'll take it up. Sure. So sprinklers around here, we use the sprinklers for germinating. The furrow irrigation probably wouldn't work as well, just because there's less coverage. I'm not sure how drip would work. We don't have the drip irrigation here, the subsurface drip irrigation at least. And also plant height. So if plants are growing taller than the sprinklers will reach, and they're going to be blocking, the foliage will be blocking the path of the sprinkler, we'll need to furrow irrigate. Time of year depends for us. We use a lot of furrow irrigation with the canal water and less with well water. Let's see. I guess that's about it. If we're fertilizing, I guess we'll want more even coverage to kind of wash in or kind of dissolve the fertilizer evenly. So we wouldn't furrow irrigate there, where we would put more water in the furrows than up top on the beds. Drip might not work as well with just a broadcast fertilizer type application, just because the subsurface drip might not actually touch, the moisture might not reach the surface in some cases, and it might not dissolve that fertilizer. So it depends a lot on our case, kind of the same situation as everything else. It depends.
Yeah, great. Thanks, Jeff. Robbie?
Our considerations are probably far fewer. We have side rolls and we have a couple of center pivots. That is the best way to irrigate there is, because that's the only option we've got.
Great, thanks. Matt?
We adapt. We have real irrigation, we have sprinklers, we have center pivot. We've done a little bit of drip, especially for plants that we're doing very, very little water on, would be those ones, sagebrush or snow buckwheats or things like that need super limited amounts, because you're only trying to juice them right at one time of the year. They get very wet, they want to die. And so the majority most grasses tend to adapt well to the real irrigation. You know, you get large single soaking events. Again, this mirrors a lot of the Intermountain West. You get a very seasonal, large inundation of water or precip coming some way, and then it goes away. The sprinklers are adaptive, and I'd say we use them more on the flowers. I mean, there is a problem is it does interfere with the pollinators, and but such is the problem of playing God. We can't do it all.
Great, thanks. And I don't know why all of our participants are so shy, but just so you remember, you can turn on your camera if you'd like to share your smiling face with everybody. It's nice to see a full house with quite a few. Thanks, Liz. Quite a few familiar names, but quite a few not. So really appreciate everybody's participation. I have a question. What do you believe would help expand and stabilize the native seed market? Matthew, would you like to start?
Certainly,
Turn on the camera. It's so nice to see you all.
So, and people might have heard me say this before, so you can just mute me if you don't like it. The native seed market has a demand problem. It does not have a supply problem. Yeah, there's a huge amount of room for more growers and users, but it has to exist. And even in a given species, oh, well, we want this and this, but boy, that little flower would be great, except it looks costly. What would we do with that? Okay, then you define the functions of what will be available for your ecologies by doing so. I mean, that it's just a demand issue. You could have a full menu of biotypes of grasses and flowers for every ecoregion, seed transfer zone, whatever area you want to call it, if demand existed. Unfortunately, this is not, again, not a normally clearing market. It is transactional. It's one transaction, two transaction. It's plant material development in a lot of it still. There are pieces, especially in the cultivars and the larger things, you will see it being used and inappropriately a lot of times. But hey, I said that. You can again mute me if you don't like it. But it's that is the case. It's just a demand issue. The market would supply it if there was a need.
Great, thanks. Pat, do you have any thoughts?
Yeah, no, I agree. It really is I think that this seed can be produced if there was a more of a demand. I think the way you get to that demand is you get people to design that into their projects. You know, you basically have this material, like for example, a lot of work is done in California by Caltrans. A lot of the seed is supplied by Caltrans, and there's a few districts in Caltrans where they have ecotype requirements. And then when you have ecotype requirements, that creates a demand for that seed. So in other parts, you know, in other districts in Caltrans, they don't have ecotype requirements. So it really, at the end of the day, you need to make sure that the specifications are driving the demand for the seed. So we have to get, you know, designers to come in, you know, landscape architects, et cetera, to come in and start designing these things that have specific ecotype requirements for projects. Once that happens, there'll be a significantly greater demand for the seed.
Eric, do you have any thoughts?
I don't think so, because I've been so removed from the market aspect. So. Okay,
that's okay. Robbie?
Definitely have a thought. First of all, I would say that I think probably state by state, there are cultures that are created over time based on the people who are the seed buyers and where the money is. And so I think that some states are much further along, whether it is through their Caltrans, it is their BLM offices, whoever might be the biggest buyers, may either have bought into the idea of local ecotypes and kind of started to hardwire that into a lot of the decisions, or it becomes much more personality and specific office or specific time frame generated. And so I would say for us in Colorado, what we see more frequently is somebody with a vision, and then they get promoted, go to a new job, whatever, and their heritage lingers for a little while, but it is not embedded in the system in any way. And so it's very frustrating for us to grow out something that actually turns out to be a great crop. And then I get an order for 50 pounds. But you had me put in a 10-acre field, you know, I invested this, and now the demand is this. And I'm not a marketer. I'm not trying to go to everybody and say this exists all the time. I don't have time for that. You know, we're a lean operation. We try and grow seed and have good seed for people, and we need assistance in that marketing piece. And it's not marketing like typical advertising as much as it is in availability and, you know, that broader notice of what's available. But then also that commitment over time to continue looking for those specific species. A lot of them are the workhorses, and so that's a much easier sell if it is slender wheatgrass or mountain brome or something like that, which does get used on 90% of the projects, versus the $100 sulfur flower or something that will be a much more specialized piece, but it still is going to have its use across a lot of applications. And so that is a huge piece of it. But I would also say the other side of that coin is perhaps for farmers like us and people who would like to be providers, we're not necessarily the scientists. And so more help in getting information about those specific moisture requirement pieces of information, or best time of planting, whatever the research is finding, getting that translated into a simple to find and simple language. And I'm not trying to downplay farmers by any means, but we don't spend a lot of time looking at all the research documents. We got to get out there. We've got a limited window of time to plant to do all these operations. And so that specific information that might help us be a little bit more, bump our success rate up from 25% to 30%, that can make a big difference in how willing we are to invest in some of those ecotype grow outs.
Great. Thank you guys. Appreciate that. Russ had a question. How do you determine isolation requirements for general grass species? Is this based upon experience, or are there reference materials out there, i.e. certified seed isolation guides? Matt, I see you shaking your head. You want to take a first stab at that, and then we'll go to everybody else.
There are guides. Yep. In our state, Washington State Department of Agriculture has requirements for the number of feet of isolation for each given species. Sometimes it's 165 feet, sometimes it's 965 feet, or whatever it is. And I believe those are published by, is it AOSA or AOSCA? I'm trying to remember who put them out, but they exist. Yep.
Great. Thanks. Pat or Robbie, do you have anything that you'd like to add, or what your experience?
I'm sure.
That show up in the screen. So this is our Colorado seed certification standards. So we get one of these every year, and they lay out it may not be for the specific species when we get into the more exotic ideas, but it still gives us our starting place and the people we can go to if we have questions about it.
Great. Pat?
Yeah, similarly, we have the California Crop Improvement Association. It's actually a little further behind, though. It's an organization that kind of got some ground maybe 15 years ago, and then sort of dwindled, and it's come back to life. So it does have some requirements for that. And then there's some literature, which describes, sort of isolation requirements. There are a few papers out there. I don't know, Jeff, do you have anything to add on that?
Not really. I can't recall who the papers are by at the moment, but it's something that we look into when planning out the layout of our fields each fall. Yeah, like someone else was saying, some of the species have different requirements. Seems like the flowers, anything a bee can pollinate, seems like the requirement is a longer range than, say, a wind pollinated grass or a self-pollinated grass.
Yeah, the grasses in particular, if they're selfing or crossing, there's a difference. I think can be as little as 60 feet for a selfing grass, and something like 300 feet maybe, Jeff, for something that crosses. Yeah, so.
Great. So Michael had a question. He says he's a total outsider, so I'm using his words, not mine. So glad you're here. Great question. From a layperson's viewpoint, there's been a lot of news about the mega drought that's been affecting the basin and range area. Is this an issue for the presenters? And if so, how are they reacting to it? Robbie, do you want to start?
You bet. It's definitely an issue for us on the Colorado Plateau also. And we do a lot of offerings to the rain gods and to the snow gods. Milkshakes are a real favorite. And we definitely base, our irrigation comes from a reservoir. And so we get predictions at the best for what the water is going to be like. So we're already making some decisions and some at least directional shifts this year as to which crops we're just going to leave fallow and not water at all. So we put the precious water where we think we've got the best chance of, getting a good harvest, of upgrading stocks that we might need, et cetera. And some of the things that we're going to experiment with are less water requirement species, just because that is the direction we seem to be heading. So I think there's a lot of tweaking we can do within our own systems, and then experimentation for future crops.
Great. Matthew?
I think it's caused damage, and it's definitely made any wild collects harder to get. I will say that. In terms of productive capacity for us, well, the Great Grand Coulee Dam on the Columbia, it makes it pretty simple here. And so, yeah, we get St. Patrick's Day to Halloween water. So it's pretty straightforward.
Okay. Pat?
Well, we're not in the Great Basin, for what that's worth, but we definitely are experiencing a couple of very significant drought years right now. However, so far, it hasn't impacted us too much, except for the fact that we have to irrigate when we normally don't have to. Right now, for example, last year we got canal water, and we do have the wells. And the canal water, Jeff, is going to start here again pretty soon, yeah. So,
but we get an allotment of water from the water district each year. This year it's much less than normal. And if we get another dry year like this next year, then there will be nothing available next year, is what I'm guessing, just from the reports that we've got this year. And let's see, I guess that's it.
one thing too is like the quality of the water differs between the canal water and groundwater, right? So we definitely would rather use the canal water if possible. The yields are better, less issues, those kinds of things. Cheaper also, right? But I mean, sometimes we're like right now we're forced to use, the well water.
And actually, with less rainfall, we're seeing more soil issues and soil pests, like insects, and also just above ground foliar plant sucking insects like aphids. We're seeing aphids on our grasses this year, which we usually don't see. We see it a little bit, but usually not enough to have to do something about. This year we've had to control aphids on a lot of our grasses, which is pretty abnormal. And yeah, just irrigating a lot more.
So kind of to go back, Brian mentioned, and I believe this is related to Russ's question about isolation requirements, and maybe that's something that USDA ARS can help develop some of those. Brian, is that what you would getting feedback from growers about what species might be helpful? Would that be something that would be good to communicate with you?
I suppose I was just thinking out loud in the chat, but yeah, I assume that these isolation distances for all native grasses and forbs, et cetera, outcrossers can be available for everything. And so I wondered if the native seed producers would benefit from this type of research done by ARS. I think it's a rhetorical question, maybe.
Well, if there's a good feedback loop, and we'll talk about this at the closing, but we definitely want to be able to share the contact information for all the participants here, so that if people have specific follow-up questions or have an idea afterwards how to get connected with you. So Dirk, I see your hand up. I'm going to get to Rhonda's question, and then I'm going to come to you, okay? Rhonda asks, if you're doing a planting project in the Tule Desert, excuse me, only using water that falls out of the sky, what are some of the best seeds to try? Does anybody have any suggestions, Matthew?
What else is growing there? I mean, There's the first one. If it's growing there already, that's what you want to work on. I would not tell you specifically what that might be at the moment.
Robbie or Pat, do you guys have any thoughts?
So I'm not familiar with that area, so I can't give anything specific, but some of the advice I give to almost every customer who comes is that nothing grows without moisture. So patience is probably the next most important thing you have after you choose your species, because if you don't get enough out of the sky at the right time, it's not going to grow.
Great point. Pat?
Yeah, same in terms of like not familiar with the area, but I agree with Matthew that definitely you want to plant things that naturally occur there as number one. And I would say secondarily, you want to use the best fit commercially available ecotypes as part of that, because that's going to give you the best adaptations. But beyond that, Mother Nature is going to dictate whether something's going to establish or not.
Great, thanks. Dirk?
Thank you. Very quickly, what Robbie showed us a little bit ago on the seed certification standards. Good question. I mean, is this super secret knowledge that only a grower can get? And if it's possible to get them from all of the different states, would that not be a good tool for us, Russ, and anybody else? I mean, can we get a hold of it and make sure that we're familiar with it so that when we do ask for product? Does that make sense?
Yes, and I'm going to let Russ take a first stab at it. Go ahead, Russ.
Yeah, Derek. Ultimately, no, this is no secret document that's hidden away in any sort of safe or buried 25,000 feet underground. So anybody has access to it. You just simply have to get into contact with your local seed certifying agency. Here in Nevada, that's us, the Nevada Department of Agriculture. We'd be happy to push that material out to you for reference, or anybody who has any sort of questions about isolation. The one thing, the caveat with that is those isolation guidelines are specific to general classes of, say, grasses that are going to qualify as certified, as foundation or registered stock material, right? So it very well might be different if you're going to be growing specific grass species that aren't really going to be categorized as, certified class or foundation class. It's more just general guidelines based upon the research that these seed certification agencies have conducted to a lot of specific or an exact number as far as what feet they believe is the appropriate border or buffer between different, cross-pollinated species or self-pollinated species in that fashion. So really they're only specific to the certified seed, right? But I think they're used as generally just guidelines for anybody that's producing any class of seed out there.
Does that answer your question, Dirk?
It does. Thank you very much.
You're welcome. Do any of the panelists have any other thoughts besides what Russ said?
Nope, I'd agree.
So the next question comes from Steve. Has anyone trialed plant responsive microporous tubing for subsurface drip irrigations as an alternative to drip ports? Could it be available, a viable alternative, with higher TDS waters? I've seen excavated microporous tubing, which has become encrusted with microbiologic crusts, which presumably are providing water with water to crop roots. Does anybody have any familiarity with that? None. Okay, sorry, Steve. James has a question. What is your experience with inoculated seeds or pelletized seeds? Does anybody have any experience with those?
My only comment is that when we did the dahlias, we did put a specific inoculant on the seed, rhizobium or a bacterial inoculant for the roots. That's the only comment I have there.
dormancy, but that's not really inoculum.
Pat?
We don't really treat our seeds too much with inoculant. We do use GA3 for seed that has a high dormancy to try to break dormancy. That's one thing that we do. Sometimes the seed that's sold, some of the legumes have a inoculant requirement for the seed that's sold, but we don't use that in the stuff that we plant. Anything else, Jeff?
Yeah, that's it.
That's it, yeah. So, also it's not an inoculant, but obviously that we treat our grasses with fungicide is one of the things that we do, but that's a little different deal, so, yeah.
Great. Matthew?
Yeah, we use a control for, at least in the fields, on fungicide for the smut, most especially, is what you end up fighting. And you can get that on in the pre-plant when you put on the seed. In the field, not as much. One thing we do use is anytime we need to include lupin or legumes, we take soil from where we grew them in the field and usually throw it a little bit in the seed mix, because it's naturally inoculated. Awfully handy.
Yeah, that's interesting.
Robbie?
So the only one that really jumps to my mind is our Utah sweet vetch. And that is a released variety. So that species or that seed has been around for a while. And when we're putting in a new field, we have a friend who does create a specific rhizobium for that Utah sweet vetch for us. We find that that is a really important factor. But otherwise, just general packages to go with the seed, we don't.
Okay. I think we'll move on to the next question again from Scott. There are numerous tools that have been developed to assist in pairing ecotypes. Oh, sorry, I just lost the question. Developed to assist pairing of ecotypes and restoration rates, generalized provisional zones, seed lot selection tool, etc. Do you prefer one tool, or is there one that is used most? Pat, do you want to answer?
So we're just now starting to get into looking more closely at seed zones as part of our kind of assistance with restoration design and clients that are asking about the best seed for areas. So I'd say we're a little behind on that. It's something that we need to work on a little bit more. Usually we look at the geographic locations, of project sites, and we try to do our best to match that. Sometimes there's not a clear answer, but when we're consulting with clients about developing a seed mix design or what have you, we kind of use our best judgment on that. But we're working towards using provisional seed zones as part of our sort of a design assistance kind of moving forward.
Great. Matthew?
If if there's a mix and we have materials from that area, that's what we use. I mean, again, not rocket science. I don't use many of those tools. They're all pretty. I like to look at them. And but if I'm looking and I do not have a particular species that's needs to be in a mix and that matches that ecoregion, I kind of go down the list, and it's up for debate, but I start with precip. What's my best next precip match? Well, nearest geography match, precip match, then soil. And by the time I've answered those three, I've usually caught seasonality too. And that gives you is it the best heuristic? But it's the one I got. So that's what it is.
Great, thanks. Robbie?
I don't really have anything to add to the conversation. I think that we're far less developed than both Matthew and Pat's areas. So no, again, if somebody needs local ecotype, we're looking for what either grew closest or most similar characteristics.
Great, thank you. So Kathy wrote quite a long comment / question. So I'm going to try to summarize it a little bit so you don't have to listen to me struggle to read in front of 100 people. So I apologize. She's talking about seed mixes and not knowing what is current demands are going to be and what projects are needing. And so we're basically, or she's feeling like she's stuck in a catch-22. It's hard to spec for native seed mixes when it's not available. And then we have to fall back on recommended non-natives that we don't really want to spec. Any brilliant ideas on how to bridge this gap? Pat, do you want to start?
Sure. So we try at Hedgerow Farms with the webpage that I had in my our sortable database that I had in my presentation. That thank you, somebody put a link in on that one. So at least we have a relatively stable supply of ecotypes that we produce that are commercially available. So, but that's for Northern California type stuff here. So I'm not sure where her project area is. So, I think it's probably lots of calls and emails to seed producers to get a sense for, the seed that's available and do their best to try to get a sense for what is going to be available in when her projects come online.
Contract grows also.
Yeah, she said she couldn't do contract grows. Yeah, but obviously contract grows are the avenue in which she can ensure she'll have the seed available. So but those tend to be much more well-funded projects. Yeah, and I think she said that at the beginning, right? She can't afford to.
I think so. Broad spectrum. Yeah.
Yeah.
And she put another chat in that she's from Oregon too. Robbie, do you have any thoughts?
Well, I do. It might not get specifically to the real depth of what one area needs. However, the regional programs that have come online, like the Great Basin, like the Colorado Plateau, like the Uncompahgre Plateau, in our area, there was a big push for sage grouse because sage grouse were in danger of being listed as an endangered species. So there was an impetus to come up at least with what would be the most important workhorse species that cover the most applicability within a regional area. And so some of those efforts are certainly one good way to start drilling down towards, different areas' needs.
Great. Matthew?
That is a huge problem. I mean, I think that is, like I've said before, there's a demand problem, and it is, but you can't contract and you can't budget for it. But if we don't know it exists, how could you even recommend it? And when we are left in that run is that as growers, we take our feedback from, well, we grew it and somebody bought it. Oh, and if they say they'll buy it again, maybe we grow it again. But that is a long loop and it has a huge leg. And especially if you're looking at projects that could be coming down the line, here's where you need, like Robbie mentioned, we need a deus ex machina reaching in saying, I will tweak the machine to make this work. And unfortunately, or fortunately, is the state able to do that and whatever the state represents? Yeah. Probably not the democratic aggregate of all of us, but it is something, and it can arguably fill some of that role.
Great, thank you. Eric, did you have anything that you wanted to mention?
I don't think so. Thanks.
Okay, I'm not trying to leave you out, but they seem to be producer-oriented questions. So I'm. If you feel like you have something, please feel free to speak up.
Okay.
Kevin has a question. Speaking of scale, what are the scales at specific ecotypes versus cultivars that can be reasonably used? Can they be used in reactive, fire restoration over 10,000 to 100,000 acres? Robbie, do you want to try to take a bite at that? Go ahead.
I guess I've already labeled that we are on the side of varieties. We know we can find those varieties to be so much more predictable in how they operate, what kind of yields we can expect, and the demand for them, that the answer is definitely for us, yes, cultivars are a better approach, but that is not because we think it's a better approach for that larger landscape need as much as it is that we know the demand is there for them. So we personally would not, it would not be in our heads to try and grow out a super large field of White River slender wheatgrass. This is the thing I'm working with right now. So that's what's on my mind. It wouldn't occur to me to try and grow out a very large swath of it, because I can't imagine which fire it's going to be, or which, situation is going to be where that would actually get used up. It more likely would sit in my barn until it started really losing germination. And then, industry secret, then I may just need to label it as VNS and variety not stated, and sell it for whatever applications just need slender. They're not so worried about a specific ecotype. So if I don't have a market, then I downgrade and just try and get that seed moving rather than just let it die in the barn.
Great. And Beth, I see that you stated some stuff in the chat about seed zones. Do you want to chat anything out? If you want to turn on your camera and mic, or does that capture? Oh, she can't. Okay. So there is an answer saying that seed zones have gotten smarter, and that it's more about climate than distance. Some seed zones are very large and get seeded all the time, and some are smaller and don't get seeded very much. So thanks, Beth, for stepping in. All right, well, we are getting close to wrapping up. I have a couple of other questions for our panelists, but I also want to make sure that we have some time to discuss and what your palette for day 2. I think some of Robbie's comments about markets and that sort of stuff definitely lead us in that direction. So if you guys, again, if you have any questions, please feel free to raise your hand or put a comment in the chat box. It's nice to see some people turn their cameras on. It's nice to see everyone. So appreciate that. So I'm going to ask panelists, and I don't think I've asked this one, and if I have, I apologize. What is one of the hardest things about working with native seed? Pat, do you want to start?
I think I'm going to have Jeff talk a little bit about this, but native seed is it's a challenge. You have to essentially do a lot of things right in every step of the process in order to be successful. So it starts from getting that stock seed, growing it out properly, making sure that you're controlling the weeds, having an efficient cleaning operation, getting it in the bag, selling it. So it's like 10 steps along the way in order to successfully grow out seed. It's really like you have to be pretty good at a lot of things.
Yeah, one of the harder things is, I guess, variability between ecotypes. Also, just getting stock seed in general seems to be really hard for even people doing contract grows who have a lot of land, and it takes a lot of seed to be able to put it into production, especially for the grasses, which are larger seeds, less per pound. So we actually need pounds and pounds, not pounds and pounds, but about 10 pounds of grass to get it to flow through our seed drill. And for someone who was wanting to do restoration right away, maybe collect 1 year's worth of seed from a site that might not even have, there might not be enough seed in that whole site for a grow out. So it might take a few years of collecting from a site, or it might take a few years of amplification on the farm. So growing a small collection out enough until you have a little bit bigger amount, and then maybe planting that, and then growing another amount that's then enough to go into the field that'll flow in the drill. So it might take, like milkweeds, it might take a few years to get enough seed to actually be able to put it into production. So that's just what came up right away, stock seed. There's, like Pat was saying, there's a million other things that go into what we're doing that make it challenging, but That's one of the main things that popped into my head right away.
Great, thank you both. Robbie?
I would say saying native seeds is kind of like saying the grocery store. There are so many different species and each one has its own secrets. So yeah, I mean, that's part of the fun and the challenge and also the failures that you have.
Great, Matthew?
Yeah, failure to grow, failure to make a seed head, failure to pollinate, failure to make good seed, failure to capture that seed, failure to clean that seed. Failure, 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 failure. Ooh.
Okay. Great, thank you.
I could give also a comment. I think you have
Yes.
to have patience and interest in learning because they're all different. That's what we found here. They're all so different in their requirements for growing them. And like Matthew said, everything. So you have to have patience to carefully try to figure out the requirements of each one and just have an interest. That's all.
Great, thank you, Eric. Brian also put in the chat that they have some ongoing collaborative research with BLM, Seeds of Success, on astragalus, and was wondering if any of the panelists have grown any of these. Do any of the panelists have any? No.
Yeah, we've grown astragalus philippis, and we found it frustrating to work with because the seed pods tend to, shatter, open up close to harvest. And so we found it difficult to work with, but we did, have a stand of it and were able to grow it, but it was one of the harder ones.
Matthew?
I have not grown any on that list, but astragalus in general is a recipe for failure. Again, that's what happens. It is, if you've ever tried to go collect it, how much fun is that? Well, I see some plants on a hillside and I hiked the whole hillside. I got 4 or 5 pods and each pod had 1 seed, and well, that's a good afternoon. I got 5 seeds. And so, no, not fun.
Okay. Great.
Can I follow up?
Yes, absolutely.
So the Seeds of Success program that some of you, most of you might be aware of, has collected some 25,000 populations. And I don't know the statistics on species, but these are all SOS collections that are entrusted to the National Plant Germplasm System. And we're supposed to keep them in perpetuity. And so we're going to have to figure out how to, regenerate these. And we have an experiment just to do that, to figure out how to germinate them, stratify them, scarify them, establish them in the field, and all the physiology involved. And we're looking at maybe some pollinator research. So, I'm just wondering, and if these are native plant species that would occur somewhere out west, are they not important ecologically, and would they not be important to be used in restoration activities?
So Matthew, or do you want to respond?
Yeah, totally important. I mean, we need native legumes. I'd say, you hit on the missing piece in the restoration menu for success. How come there's no legumes on my menu? And yeah, we need those, especially for dry sites. But they are not well adapted agronomically, at least not yet. Okay, certain ones are better than others, but wow, I don't want to talk about the tuition that's been paid to learn what I don't know on astragalus, because that's expensive. You can ask my banker maybe, but it's unpleasant. They do not work well. I mean, we've done woolly pod, we've done spirocarpus, we've done balloon pod, we've done, oh brother, Philippines. And so there you are. You can have them. And I hope somebody else figures it out, but I ain't figured it.
Great. Eric or Pat or Robbie, do you guys have any other comments?
Nope.
Nope.
So a couple of comments in the chat, and maybe some questions. One from Scott: an important outcome of today's discussion is the disconnect between what can be successfully produced and what someone might see on the landscape and want produced. Coordinating species selection with these experts is valuable, and totally agree. And I don't want to do too much of a side plug or toot NNSP's horn or our plan, but we have a great strategic plan, and that is definitely a part of that plan, is trying to work on that exact question, whether that's producing seed menus or other avenues, so that we are bridging that gap and producing what needs to be produced and used where it needs to be. Kathy says, better test them for all poison qualities through the Logan Poison Lab and know if they're putting the astragalus out on sites. Ed Kleiner says, we have clients that have target lists for us to collect in their region, but will also be receptive of additional species that produce seed while we're in the area. This contract flexibility is essential given the serendipity year by year. And that's very true. And I think that's some of the things that hopefully Brittany and some of the other contracting discussions will have tomorrow about how we're learning to be flexible in our contracting and seed collection and seed use and seed menus, so that we have the flexibility to be able to do that. Kevin asked, what attributes qualify a species for agronomic production for maintenance and harvest? Matthew, do you want to start with that? And then we'll go to you, Robbie.
Okay. Yeah, sure. First, do you want to live and do you want to stay alive? Those first two questions for a plant that you're going to put in the ground. Man, sometimes that just doesn't work. In terms of agronomic development, I mean, again, so part of the question becomes, if you have things that are agronomically successful, they may not be ecologically successful, and that can be bred out of them too. And it makes them, again, they can become almost a pest then, rather than, you know, something that you want in that niche. That said, obviously, being able to be handled mechanically, you know, having a determinate seed shed, being able to hold that seed for all the features that made wheat and barley so great, why they came out of the Fertile Crescent, and the ones that they threw away 10,000 years ago on the road to get here. So yeah, look at all your egg crops and say, these are the agronomic features. And even some of them, you know, oh, sugar beet seed, so hard. Well, sugar beet seed is a walk in the park compared to trying to get your local needle grass to do what it's supposed to do. And so those agronomic features, that's the variance. So when I see it, certain things, you know, the grasses, especially something like, you know, mountain brome is almost like an agronomic crop. It has a lot of features. If it wasn't for the seed shed, it's almost agronomic in a lot of ways. But yeah, there's some examples.
Great, thanks, Matthew. And Kevin put a qualifier or a clarification. What are the attribute managers can look for that will assist you in production? So with that caveat, Robbie, do you have any other thoughts?
Well, you might remember the one slide I had in my presentation with the bucket of seed plant. Harvest is a huge, huge piece of the whole puzzle. So you can be a great farmer, you can get a lot going, but if you can't get it into the combine, into the barn, you don't have a crop. So, you know, that 6 weeks fescue, 10% of the crop actually may get into our barn. So that says two things. Number one, it really does play a role in what we would choose to accept as a contract to grow out, or accept, you know, just on our own effort to try and grow, if it looks like we can actually make it all the way through the process. And perhaps it's a challenge to some of our scientists and our real creative ones for more methods, more tools that would help us with some of those really difficult crops.
Great, thanks, Pat.
Any thoughts?
Yeah, those are all really important things to think about, and definitely things that we look for. But yeah, the main thing, or one of the main things, is like Big seed seems to be easier to harvest. Like taller plants are easier to harvest. Something that only grows 2 inches above the ground, our harvester can't even cut that in most cases. So the height, the seed size, kind of maybe the seed shape. Some things that are really, really fluffy, like I don't know, rabbit brush. Just trying to think of something that might grow near you guys. We tried to clean some of that for contract grow last year, and what we cleaned out wasn't much cleaner than the material that came in. So that one, and just things that it just from experience, really, things that you wouldn't think would clog up a combine. Sometimes seed gets stuck in the material that it's like the seed will get stuck in the leaves, and you can't separate the seed out of the leaves because it's too big, or it might get blown out with the seed. So yeah, just characteristics like a regular agronomic crop is kind of the characteristics that we would look for and find the easiest to harvest. Yeah, just yeah, like you were saying, most of what we harvest is really tricky. So it takes a lot of just trial and error and learning and a lot of failures.
Great, thanks, Jeff. Eric, do you have anything else?
Well, I was just going to say, it's almost like you need to adapt to the crop because they're so different. And it's hard to treat it like a corn crop or a wheat crop. I mean, yeah, some of them we were able to harvest pretty well with a combine, and actually the seed came out pretty clean out of the combine, but those were rare. It was just so complicated. Everything was complicated, different from one to the other. You almost have to adapt to you know, do your research and adapt to your species.
Great, thanks. Beth Ledger made a comment about this. She says it's rough. Seed holding is great for agricultural production, but in the wild, it makes seeds likely to get eaten before they hit the ground and they can't disperse. So it's a balance. And she also echoes that cleaning rabbit brush is terrible. And Scott said plant height is an important criteria. Mechanical harvest is imperative for economical production. We haven't yet success fertilizing a short crop to an adequate height for mechanical harvest as well. And I think that's probably in your failure discussions and talks of complicatedness. I'm sure that is true and been encapsulated. Does anybody else have any final questions for our panel? Really appreciate you guys being here, and your presentations were fantastic. I learned a lot and really appreciated it. And we had a great turnout. I think our highest participant level was like at 120, and we still have 84 people. So thank you very much for everyone who participated. Thanks to Liz Munn for our tech hosts and helping us. It's been so nice to focus on just moderating and not have to worry about all the rest of it. So thank you very much, Liz, for that. Thank you to our panelists. So I want to give you a little bit of information about day 2. So day 2, we'll have information about market for selling native seed in Nevada, including presentations from UNR Extension, the BLM, Nevada Department of Wildlife, Nevada Division of Forestry, and Nevada Gold Mines. Again, there'll be a panel discussion at the end, similar to today. And I had one question for those that are still with us. We'd like to share the attendee list with everybody that attended. So if you do not want your contact information shared with everyone, please send an email to Russell Wilhelm, who you coordinated with, to get onto the Zoom call, and he'll make sure that your contact information is removed before we share that list. But we really wanted to make sure people could have an easy way to get in contact with each other and see what organizations everybody is from. So again, really, really appreciate everyone's participation attendance today. It's been fabulous. And thank you to our great panelists. Really appreciate you guys taking the time and sharing some lessons learned for us, for our producers and for our state. And I think I'll leave it at that unless anybody else, Russ or Liz, have anything I missed.
Well said, Megan. I mean, I would echo everything entirely. Thanks so much to our panel of speakers. It was great. Fantastic.
Wonderful. And there's lots of great chats. So make sure to look at those, and we'll see you guys all tomorrow morning. Thank you again so much. Really, really appreciate it. Take care.
Thank you.